And where are we today? We're simply accelerating. In this industry, you can't slow down. And it is our roadmap that is driving us to continue to innovate from rack scale for the largest of hyperscaler and sovereign AI implementations to, of course, our PC and embedded applications. Our competitor is developing an AI area more proprietary and walled garden solutions. But we are leaning in going forward on commitment to open software and open hardware AI ecosystems. And Lisa talked about this incredible pace of scale, of expansion of computing to meet the demanding cluster needs, the growth of incredible computing that we need. And so that's where we're leaning in as well. We've got the I/O technology that we brought in-house through SerDes, investments in our networking capability, as well as the technology that we've done to link as we bring these clusters together. And even more than in prior applications, security is critical. AI needs to know that your data is entrusted, the customer's data is entrusted, and we've extended confidential computing to AI clusters. Well, let's dive down a little bit. We'll start with CPU roadmap. Zen really reshaped what CPUs were delivering in the industry. If you recall, the industry had plateaued, innovation had died off, and Zen brought back significant performance improvements every generation, over double-digit percentage of performance and customer value that we delivered. This came with more core density, a higher efficiency, and economics that we brought, leveraging our approach. You look at Zen 5, we repipelined for yet more performance with every core that we added. We have also added AI support. So people don't realize that vector engine in Zen 5, it's a native 512-bit wide vector engine, along with the software support that you needed, is an outstanding inference engine for a number of applications that are not the most demanding that require GPUs. Our next generation of Zen is Zen 6. Zen 6 is in our next-gen EPYC that you'll hear more about from Dan later in the agenda. It was the first tape-out in TSMC 2 nanometer, and it's going to further extend our leadership across our CPU, both performance and efficiency. And we continue to provide 2 core variants, one optimized for performance, one optimized for efficiency. And I talked about that consistency of instruction set architecture. We're now over a year in having successfully stood up with Intel an advisory group that drives alignment of the x86 software or instruction set ecosystem, protecting those billions and billions of lines of code that customers have out there with x86, safe chasing their investment. Let's talk about AMD Instinct, our data center GPU. Since MI300 was launched in late 2023, that marked a shift to an annual cadence of development. So with that, that meant CDNA, our GPU building block for the data center, also went to an annual cadence, driving generational improvements in compute as well as memory performance. CDNA 4-based MI355 is ramping incredibly fast right now. It's expanded AI math formats, including block scale for accuracy preservation. Our CDNA 5 is what makes up MI400 series, launching next year. Also, expanded math formats for more efficiency, and HBM4, bringing leadership memory capability. And just like the CPU, which remains on an alternating design teams, everything through Zen 6, even beyond Zen 6, Zen 7 in design, we do the same thing with our GPU. And so we have MI500, our generation next, well in the design phase, driving yet more compute, memory, and interconnect technology. And what has happened with this annual cadence that we have, it's a requirement, just given the pace that we see of that explosive, insatiable demand of AI computing. If you look at this curve, it's showing flop rates. So that's the computation rate that we have in our GPUs. And prior to 2025, you can see that we were on a doubling pace of those flops every 2 years. After 2025, it's doubled. We're on a 2x every single year of that capability. And that's with a baseline of 16-bit math, one of the more predominant math formats. But again, optimized math formats, yet again, increase your performance. And so what you see is on top of that baseline at 2x every year, FP8, which is 8-bit math, provides a doubling again of that baseline. And FP4, 4-bit optimized math, doubles yet again. This is a compounding, exponential growth rate of computing that our industry has not seen before. So I mentioned earlier SerDes, and it's really the first time that I've done a deep dive on SerDes, and it tells you about the expansion capability and connectivity that's needed of our industry. So SerDes are front and center. We saw this coming. So what we do is look at the standard in I/O, PCIe. And back in several years ago, in 2022, we in-housed the design of that PCIe Gen 5 because we needed more performance, more optimized implementation. Because when you look at the math of how that's deployed across our portfolio, in fact, that implementation has actually already shipped tens of millions into the industry. Well, we got further skills because upon the acquisition of Xilinx several years ago, we immediately brought the SerDes teams together, and that brought 112 gigabit per second interconnect technology that was used in networking right into the AMD portfolio. And so that's, of course, shipping already today in the Versal FPGA, but it's also the SerDes underneath our PCIe Gen 6, which powers our next generation server, codenamed Venice. And now you look at where we're going in the MI400 series, in that Helios rack that Lisa mentioned. We double to 224 gigabit per second technology. And that's critical for our scale-up capabilities, and I'll expand on that in just a minute. Where's the industry going? It's not slowing down. Copper is going to 448 gigabit per second. But in that signaling technology, when you look at the number of wires you need for the bandwidth we need and the power dissipation, it's going to start the transition at rack level to optics. And so we're preparing both technologies in parallel, both 448 gigabit per second copper, as well as investments and roadmap that we have for optical. So we will manage that transition. And then I always love talking about the Infinity Fabric. I've often called it the hidden gem that we have. And you look at what we're doing, we've continued to innovate, and that's what gives us the scale that we have to be able to power these leading edge, number one, number two supercomputers in the world. The growth that we've had in hyperscale applications across both inferencing and training rely very, very heavily on the ability to seamlessly add cores and have that performance scale, and then interconnect from chips to socket to rack, and in fact, even to scale out as we build out the clusters. When you look at what we did with our third generation, it powered our first leading supercomputer, the Frontier system. Now it's number 2 in the world because the fourth generation expanded its capabilities to power Frontier. And Frontier is currently the number 1 supercomputer in the world, but it also showed that versatility of the Infinity Fabric. that baseline of the MI300 that you see in that Frontier supercomputer, with swapping out chiplets, leveraging the versatility of this IP, you have then the MI300X, which powered our AI system development, and the MI300A, and then the MI300X, which is a CPU-only version, which powering Microsoft Azure highest bandwidth CPU that they have in their fleet. So CPU only version, CPU in integrated GPU version, and a GPU only version, all with the versatility that we provide with our 4th gen and beyond Infinity Fabric. And that leads us to 5th gen that we're introducing today. It's poised to deliver for the MI400 series next year with the Helios rack. It's optimized for best-in-class efficiency across chiplets and sockets, delivering the memory bandwidth that we need to support that advanced system, and it's engineered to support open standards. And of course, like our other IPs, we're well at work on the generation beyond 5th. And I want to talk about chiplet and packaging, which has been a historic strength for us. We've been a long-time leader in this area, delivering differentiated solutions that have allowed us to push forward beyond the effects of a slowing Moore's law. We're now in our nth generation, but you have to remember the beginnings. When we started with our first generation EPYC, we implemented, as you see on the far left side of the slide, with chiplets, 4 distinct chiplets that we brought together. And it started us on a path of really leveraging that partitioning capability. You look at later in the server roadmap, we changed that partitioning to be separate compute dies and I/O dies, and we started stacking 3D V-cache. It gives us an astounding performance capability. In fact, we're in the 4th generation of that stacked SRAM, that stacked V-cache, still without a competitor in the industry to that capability. On the GPU side, this packaging, this chiplet and packaging capability has been critical for us. It's what delivered for us with the 3.5D that I described a moment ago with MI300, that flexibility that I described, and an incredible density, giving us the TCO advantage in our 300 and MI355 roadmap. But we take it even beyond that for MI400 series next year. We actually have a doubling of the packaging interconnect density, and so that gives us an incredible silicon packing capability in the next generation. And so when you go back to that start of the first EPYC chiplet implementation to what we use for the Helios system launching next year, it's a 30x increase in the silicon available for compute and memory on that design. Just a significant impact that we've had with our roadmap and our implementations. Well, look, I want to show an example. All of this technology is nothing without its ability to come seamlessly together in a solution, and Helios is that best example. It's proud to show off the capabilities that it has as it brings together our next-gen CPU, our next-gen GPU, our next-gen interconnect technology, our next-gen SerDes. All of those technologies I just described come together to give us the link technology for the compute and link technology that we need for leadership capabilities. And it also highlights the co-optimization that you need when you're at an era of rack scale. ZT Systems, the design team of ZT Systems, was a huge addition for us in optimizing across all of those elements for a performance per watt across those compute elements, right through all of that interconnect for leading edge efficiency. And it goes beyond that. It requires software co-optimization as well. So the ROCm facets of the communication libraries and the optimization of the workloads also are co-optimized at rack level. I'd love to pull out a compute tray and just give you a visual of how this all comes together. What you're seeing is our foundation IP as well as all the glue IP coming together here to have an incredibly dense sled, our compute tray that we build on to create that Helios capability. You're seeing incredibly tightly coupled GPUs. You're seeing those connected, leveraging our Infinity Fabric at 112 gigabit per second. You're seeing our ability to use standards. So it's a UA link, which is connecting those GPUs to our AI NIC. And it's UA link packetized and run over Ethernet that's giving us scale up capability in the Helios system. And there's one thing that you don't see as you see the physical elements here, but I described it earlier. And that is those security blocks that I mentioned earlier are, of course, embedded in all of that elements. And why is that important? Is that we're now delivering security and confidential computing to AI cluster level. And why is this important? Well, it becomes so important right now because what does AI do? As you are running your company and you're building models, you're training your data, all your data that you spent decades building up and creating weights, they become your crown jewels for your company, and it has to be safe-chased. So what this capability does is it provides encryption. It's an end-to-end encryption. It's encrypting data that's at rest, data in motion. The keys are owned by the user. You get it from a key server. And it is ensuring that any visibility in that entire traversal of the data, all you're seeing is encrypted information. And so this is enabled with the 5th gen of EPYC that's already shipping today. It's a standard called TDISP, or Trusted I/O. And you'll see in the AMD portfolio next year, and with other industry partners, we now extend this to heterogeneous clusters, CPU, GPUs, storage devices, networking devices, all protected with this important capability. Well, now I want to shift gears a little bit after going through a set of IPs and the example I showed you for data center and cluster applications. And I want to talk about our gaming GPU roadmap. We've been on a continuous journey for driving graphics capability and now AI capabilities with our Radeon and Ryzen roadmaps. And it is powered by the RDNA IP. RDNA 2 had brought a ray tracing optimization to bear. But in the next generation, in RDNA 3, tensor engines were added. So it was the introduction of AI to even further improve upscaling capabilities, giving you more lifelike images. Well, with CDNA 4 shipping today, we have even further usage of AI, and it's doing a couple of things. One, incredible upscaling, so you don't have to look beyond FSR4. If you're a gamer, if some of you are gamers, I'm sure if you run FSR4, you see an incredible gaming experience while upscaling to beautiful visualization. And it's not just about improved gaming experience going forward in this roadmap, and you'll hear more about it from Jack going forward. But as we further improve all of that machine learning for our ray tracing capability, it also enables these devices for edge AI applications. And then, of course, our AI engines, our neural processing units. We announced the first dedicated NPU accelerator in CES 2023, and it began shipping later that quarter. Our 2nd generation of NPU was focused on performance per watt improvement, more TOPS, of course, at each generation, but it really unlocked the capabilities in Windows Copilot+. And so these are all powering our AI PCs shipping today. And then our 3rd generation NPU, well in design, is going to bring another significant improvement in both TOPS, processing capability, but even more energy efficiency. And that's not only important in an AI PC that you have in front of you, the battery life that you gain, but vitally important for the edge AI applications, which you'll see growing in application with this technology. And as we wrap the IPs that really bring our solutions together, we've saved the best for last, because when you think about AI, it's software, and it's our ROCm stack that is the foundation of giving the experience and the ease of deploying on AMD. And our ROCm stack is now fully battle tested. It's been battle tested in high performance computing in those top supercomputers. It's now been battle tested by the most demanding hyperscaler customers. But we've also expanded. We've expanded, if you look at the last year, our adoption in enterprise is going up, and therefore the ROCm support for enterprise, as well support for the open community and bringing the additional power of developers across the world behind the ROCm subsystem. So when you look at this capability, what you see is that we now have ROCm as that common foundational IP tying together the AI experience from data center and those most demanding applications to gaming applications and edge AI that you can run on Ryzen and Radeon, and right in to those embedded APUs that we have as a growing part of Salil's business. Tremendous progress on a ROCm AI stack. Well, look, I want to wrap up with one key message to you is that as we've implemented all these technologies and partnered so deeply with our customers in driving the market share gains that we've had, it's done something else, because we become a trusted partner with our customers, and we hear clearly from their standpoint where the market's going. Data center explosion, you've already, that's amongst our largest opportunities right now, and we're addressing that with the rack scale investments from GPU scale that we've made. Agentic AI and the processes it kicks off, it turns out, are driving much higher CPU workloads, whether it be retrieval augmented generation, the test phase of a research AI application you're running, or simply agentic agents kicking off many traditional scalar workloads on GPU. We're seeing this as a major, major growth vector. And likewise, the edge AI explosion is starting now, and we are poised with our integrated CPU, GPU, NPUs to take advantage. So those three trends are upon us now. They're going very rapidly, but we're also super excited. I'm personally very excited on agentic AI. We start already with robotics today, but it's going to be a vastly growing market. And quantum computing. Our FPGAs are used today, predominant to implement leading-edge error correction. Our FPGAs are also controlling the multi-state quantum of many, if not most, of the quantum developers. But what actually gets me most excited is what we're doing to bring CPU and GPU classical computing, and optimize it with the quantum computer as an accelerator. And super pleased with the work we've started with IBM and the partnership we've announced, and we'll expand that with other quantum providers over time. So look, I just want to wrap by telling you that AMD is absolutely fueling with innovation that insatiable demand of computing for the AI era. Our roadmaps are designed to consistently provide product leadership and to leverage that broadest of IP portfolios. The open software and hardware ecosystem that we have, giving both diversity of solutions and choice to our customers, and lastly, our relentless execution. We are collaborating with our customers and ecosystem partners alike to provide differentiated solutions and leadership products. Thank you very much. And with that, I'm thrilled to bring up my close partner, Forrest Norrod, our data center leader.
Thanks, Mark. Thank you very much. It's a pleasure to be here. Thank you all for coming. I started at AMD 11 years ago, shortly after Lisa became CEO. And the mission that she set for us was to re-enter the data center market, not to participate, but to be a leader. And at that time, we were facing a dominant competitor that had nearly 100% of the market. And so we knew that in order to make headway, to fulfill this mission, that we would have to build a strategy that incorporated a leadership product roadmap, a long-term strategy to rebuild and build customer trust, and a product and a solution set that was truly differentiated to induce people to give AMD consideration and then to make that switch. Now, we implemented that roadmap based on our understanding of where the data center industry was at the time and what would happen to it over the next decade. We knew that virtualization and cloud would continue to grow. That was clear. We also saw that the explosion of data was going to continue unabated, that the conversation would shift from terabytes to petabytes to zettabytes of data flowing around the world's IT systems. And we also saw at the time the beginning of heterogeneous compute, the beginning of the era of the CPU and the GPU collaborating together on HPC and early AI applications. And so we built a roadmap that differentiated in areas that were relevant to those key trends. Higher core densities, leveraging our chiplet technology, higher memory and I/O bandwidth, more flexibility in both, all things that were directly relevant to where the industry was going. And so we built a multi-generational CPU roadmap, and Dan will talk a little bit more about this as well, that steadily increased its differentiation every generation and took more and more leadership with each new CPU, such that over time, we have grown our market share in server CPU to over 40%. We're the de facto standard in the cloud, and we're viewing this 40%, as Dan will tell you, and Lisa already hinted, as just a milestone. We are far from done with growing in the CPU. But now we face today a new dominant competitor, a different dominant competitor, and a different changed future of the data center. Clearly, AI has changed the data center substantially. The AI factory, the transformation of the data center into the AI factory is obviously the most urgent trend to produce systems at gigascale that can efficiently train and efficiently infer to deliver business value from AI. And that's happening, of course, at unprecedented scale. We all know it. It's embedded in all of the discussions we've just had, even on the TAM. And so that unprecedented scale means performance and power, in which we've historically excelled, are critically important. But even more so, you need reliability and resiliency to ensure that when you're building systems at that scale, that they can actually sustainably deliver the value that the customers need. One thing we don't see, however, is we don't see a monolith in the data center. We don't see that the data center is dominated by one particular element. Instead, we see GPU racks as absolutely central to the data center, of course, to power the LLMs and power the AI engines at the core of these AI factories. But they're useless without the sea of data that fuels AI, without the storage systems to give them the data to train, to give them the data to infer, to give them the data for agents to actually operate. And then, of course, those agents, the tools now that LLMs use, all of the databases and other systems of records that need to be accessed for LLMs to actually deliver business value, run on general purpose compute racks. And so we see a rich and vibrant data center in order to deliver these AI factories. And so we've built our data center portfolio over the last few years to address these needs. Vamsi and Dan will talk about our GPU and CPU roadmaps in just a moment and the software that makes them sing. And then I'll come back in a few minutes afterwards and unpack our networking strategy and tell you more about how we're putting all of these elements together into compelling system and cluster level solutions. So with that, let me first introduce Dan McNamara, the SVP of our server CPU business. Thank you.
Good afternoon. So 3 years ago, at this forum back in Santa Clara, I laid out a vision on EPYC, and I relayed that we really believed that we were a strong contender in server CPUs. And we felt like we were going to really go on a new era of growth. And I'm super excited to be standing here today and tell you that we have moved from that strong contender to truly the de facto server CPU leader in the market. And here's why. We delivered on the strategy we rolled out. Since then, we've delivered 2 new leadership generations of product with EPYC, with the best architecture, the best advanced packaging, and advanced processes. We've doubled down on our customer and partner network, building a vibrant ecosystem. And as Mark just said, we've continued with our maniacal and relentless focus on execution in creating a predictable cadence of products delivered to market. And we've built a very good amount of trust in the marketplace. But most importantly, all of this has enabled us to accelerate our path to #1 server market share. Now let's look at the driving forces going forward. So Lisa and Forrest both talked about the fact that we've been on a great journey, and we have, and we're hovering around 40% share. But what's more compelling is that we've never been in a better technology and market position, and at a time when the market's inflecting with AI demand. And if you think about it, it's really because we focus on the key needs of each of the segments that we operate in. With cloud, it's very well known. It's high density, performance, and efficiency, and driving generative TCO gains. And we've done that repeatedly through 5 generations, and that's driven a fair amount of share for us at this point. In enterprise, it's a little bit different. You have more performance per core, memory per core, trying to drive consolidation and modernization for the customer. And that's critical. In addition, though, there's very beefy enterprise workloads that you must have that performance for to run the enterprise. And then lastly, for HPC, it's all about flops per node. And we continue to drive floating point performance to drive key workloads like oil and gas discovery, genomics in that area. And we continue to lead in that area also. And lastly, as we talked about, AI is a horizontal, and we will continue to optimize for performance and TCO across the various use cases that I'll talk to you about. Now, let's spend a minute or two on the roadmap. And, Mark hit this, right? Our foundational element for our products, every time we start in planning, is to show Lisa a couple of different things. What's the density, the performance gain, and the efficiency gen on gen? That's table stakes. But, as Forrest just said, with every generation, we make deliberate decisions from customer feedback and market demand. And you heard Mark say about Naples, we started in 2017, but with Rome, we drove a chiplet strategy that doubled the thread density and generated the highest performing CPU in the market. Broke through in cloud very strongly, enabled us even in the enterprise on some high-end workloads, and obviously kept us very strong in supercomputing. And then with Milan, we doubled down on performance per core and drove an IPC gain, and we basically drove an inflection in the enterprise for us across both vertical/industry workloads and general IT modernization. And then 4th gen, we came back, and the market gave us feedback that we needed to dual core optimization, so we drove very high performance core with Genoa, and we also drove a very high density and efficient core with Bergamo. And both of those are shipping in very, very high volume even today. With Turn, we did more. We brought more density, more performance efficiency. We kept the dual cores, but we did some AI optimizations. We added to the AVX 512 block. we added a market-leading 5 gigahertz FMAX part for two things. One is for EDA workloads, but the other one was for CPU host to GPU nodes and clusters for either inference and training, and I'll talk about that. And then we are very, very excited to deliver Venice next year with more density, more efficiency, more AI optimizations, and driving the best performance per system watt. So now let's talk about the segments we service. One sentence for cloud: the cloud runs on EPYC. And we've been at it for a while with cloud, and it started with Rome. And we've expanded our offerings and optimization points for the various different workloads. It starts with traditional lift and shift, which was really the beginning of cloud. Those workloads like ERP and email and online transaction processing, that's all about TCO. And we deliver 50% performance per dollar better than our competition. And then there's mission critical workloads for both enterprise and cloud native companies. Think of content delivery, think of collaboration tools, think of database and analytics. That is all about VM performance. And there, again, we deliver over 70% better VM performance than our competition. And then what's been emerging for the last 3 to 4 years is HPC in the cloud. And these are traditional HPC workloads that are, being accelerated by two different products: the high frequency SKU that I talked about, but our X3D, over a terabyte of L3 cache, accelerates simulation performance by over 2.7x, and in some cases 3x. So you see, the cloud has been. We've been accelerating with the cloud right from the beginning. But more lastly on this is enabling, all of this is enabled through our security features for hybrid cloud adoption and multi-cloud adoption, which is very, very important going forward. So all of this value Lisa talked about, we've earned the trust of industry leaders. Top 10 of 10 social have their platforms deployed with EPYC. Largest cloud native companies deployed with EPYC. But one of the more interesting things that I'd really like to talk about is the Fortune 500 mainstream enterprise customers are now in their hybrid and multi-cloud environments adopting EPYC in third-party IaaS faster than anyone. We've seen a 3x adoption this year. And what that does is all of that drives back to the on-prem and drives enterprise adoption on-prem so that the hybrid multi-cloud is end-to-end on EPYC. And speaking of enterprise, we've been very, very focused on enterprise for a couple of years, investing very heavily. But one of the key focus areas has been our ecosystem build-out. So I'm very excited to say that our platform growth is 3x over the last 3 years. We've got almost 180 platforms, from racks to blades to towers to edge devices. We've got 3,000 solutions in the market on top of those platforms. Another 3x growth from the last time we had this forum. And our OEM and ODM channel is very, very excited and has shifted most of their work to be time to market with us on every different launch. Secondly, one of the areas where we break into the enterprise is what we call industry or vertical workloads. And these are what I always say is these are the workloads that drive the end business. So in semiconductors, that's EDA. In telco, it's the network. And the goal there is to accelerate those workloads in either driving more throughput or drive faster time to market or faster time to results. And we almost double our competition in terms of faster time to results. And then lastly, core IT modernization. That is all about driving TCO savings. And with our latest generation, we have an 8-to-1 consolidation factor from our competition that, along with our density and performance, drives up to 80% TCO savings for the enterprise. So all of this is accelerating the adoption. And we look at three things when we track our adoption. First is top customers. Are they using us? As you can see here, over 60% of the Fortune 100 are using us. And that's growing quarterly. We track that very, very closely. The other thing is, are we getting new customer acquisitions? These are the first time with EPYC in their fleet. We've doubled that year on year. And then probably the most important is the customers who have used this in the past with either Rome or Genoa or even Turin now going forward, are they using us more? Are they expanding their usage of EPYC in the fleet? And again, we've seen double the consumption year on year. So the enterprise conversation has changed quite dramatically. And we're very, very excited to see that change because we've been investing very heavily here for the last few years. Now, HPC, it's sort of our legacy from Naples, right? We've been winning over the years with EPYC and even Instinct across national labs, research institutes, across some of the most important workloads like genomics and oil and gas. And now it's shifting towards AI for science. We are in a third of the top 500 supercomputers. We're 12 out of the top 20 green supercomputers. And we continue to evolve our solutions. And you're going to hear about this as HPC evolves to AI for science. And Vamsi will talk about this. With our MI 430 and 450 in Venice, we will continue to drive more and more performance there, but also provide our customers the much needed silicon diversity and open ecosystems to really participate and enable this market going forward. Now, with AI, I did want to spend a couple of moments here because I believe there's a thesis out there, and Lisa mentioned this, that CPUs have been cannibalized. And I want to spend a minute and tell you what we're seeing because it's the exact opposite. And there's a number of different reasons and applications why this is happening. And first, probably the most well-known is the head node, right? The CPU host to the in an 8-way server, GPU server. And what we did there is we saw very early on, and we built a Turin product to drive very, very high frequency, a solution. And the reason is the server in this mode, in the cluster, is really more of a synchronizer and orchestrator. It doesn't have the biggest job, but if you can drive high IPC and high frequency and keep those GPUs fed with kernel launches and all the orchestration, you can drive overall performance up on the cluster. And we've showed that over and over across both training and inference. Secondly, probably the biggest conversation I have through the course of a week is just creating an AI-ready data center. That's driving consolidation. That's driving energy efficiency. That's creating more space. As our CIOs our customers are trying to drive how they go develop an AI infrastructure and modernize for the future. This is front and center. How do you do all this, but also enable those most critical enterprise workloads to boot? And then the end-to-end AI pipeline is also expanding quite rapidly. And you have pre and post processing that's happening, and it's driving all sorts of new workloads like RAG and ETL and new storage workloads, and then database, more analytics. So all of that today in the enterprise is on x86. And then CPU inference with the explosion of SLMs being fine-tuned for domain-specific applications. The CPU is now playing even a bigger role in inference because it's a cost-effective way to infer on a smaller model. It also is in a mixed workload environment because CPUs actually have multiple jobs with our high core counts. Leveraging the extra core counts there for inference, real-time inference, has gone extremely well. We have many, many examples of that. And then lastly, agentic and autonomous agents. And Mark mentioned this, but as the agents grow, more and more CPU cycles are needed to drive the interfaces between the agents and all of the real-time enterprise applications and the enterprise-wide structured and unstructured data. It's critical to drive this interconnect. And you've all probably heard of the concept of an MCP server. So see, all of these 5 applications and usage models for CPUs is driving what we believe is a very strong inflection point in CPU TAM. As you look here, we're going to add 30 billion in CPU TAM by 2030. It's basically doubling the CPU TAM in this horizon. And as you can see right here in terms of 25 to 26, the inflection is right now, right? With the agents growing, with SLMs and all of the things we've been talking about on inference. So very exciting for us because I'm coming back to what I said earlier. We have never been in a better position from a product standpoint with Genoa, Turin, and headed to Venice. And then speaking of Venice, we're going to launch that next year. It's on 2-nanometer TSMC process. It's looking great. Our cloud, our ODM, OEM, and cloud partners are all bringing up systems and looking very, very good. We believe we will have the biggest ecosystem at launch next year when we bring that out. And not only does this maintain our leadership, this actually widens the gap from our competition. We cannot wait to launch this product next year because it will absolutely be part of that curve that I just showed you. Now, let me close with where I started. The execution of our strategies got us to this point, and we are in a great position to continue the acceleration of the leadership. We will continue to drive our cloud expansion. We're hitting the tipping point in enterprise, and that we expect to grow, and we're extremely well positioned for this AI growth. And there's not a question in our mind that we have a clear path to greater than 50% market share. So thank you, and I'd like to introduce Vamsi to the stage.
Good afternoon, everybody. I am super excited to be here to talk to you about all the progress we're making on our AI strategy. Now, one of the real privileges with my job is that I get to talk to AI innovators across the world, people that are doing incredible things, inventing new drugs, solving new math that has not been solved before, tackling really, really hard problems. And as we've made progress with our strategy, what's been really amazing for me to watch is that more and more of these breakthroughs are actually happening now on AMD systems. Whether it's researchers at OpenAI or developers at Meta or enterprises like Tesla or numerous startups that are doing exciting things on our platforms, everybody is now proving that they can do their most advanced AI development on AMD platforms. So what I want to do is tell you a little bit about our strategy that's making all of this possible. Our strategy is based on 3 core pillars. Right? First, delivering leadership roadmaps. Second, providing world-class open source software. And third, establishing deep partnerships with the leaders that are defining the future of AI. And as we made progress executing to our roadmap, as the open source community embraced AMD, as we established the right routes to market, more and more adoption came. So I want to give you guys a little bit of a sense for our progress with a few examples. Just 18 months ago, if a user wanted to go develop on top of an Instinct platform, well, there's no place in the cloud they could go to. Fast forward to today, we have like a dozen clouds now. We have 35 platforms that carry AMD GPUs. Similar story on the software side. A couple of years ago, if you went to the leading AI frameworks and said, hey, I wanted to develop on AMD, support was not guaranteed. We fixed that. We worked with all the top AI frameworks systematically and said, let's support AMD GPUs. A good example is the partnership we set up with Hugging Face 2 years ago. At that time, Hugging Face model support for AMD GPUs was not guaranteed, but we worked with them to make sure that that is fixed. And today, all of the Hugging Face catalog of models run AMD GPUs successfully. So as we made progress, more and more workloads came and customers started adopting, whether it's Microsoft with their GPT model or Meta with their recommendation models or X with their Grok models. Customers are trusting their most important workloads today on AMD platforms. So now, following the success of our MI300 products, this June, we launched our MI350 series of products to market. These GPUs were launched to address the huge demand in compute that existed and brought with them innovations like 4-bit compute, the next generation memory system that allowed AMD to stay at the leadership level on memory capabilities. And most importantly, we made it super easy for people to migrate onto this platform, both from a hardware perspective, system configuration-wise, but also from a software perspective. And that's why the ramp for these GPUs has been smooth, and they're delivering excellent performance. As you look at inference serving on leading models like GPT, OSS, or Hunyuan Video, these GPUs deliver excellent performance. to look at how easy it has been to adopt this platform for critical workloads like GPT. When it first came out in August, the latest GPT OSS model, it ran on day 0 on MI355, just a few short weeks after we went to production. And we introduced support for 4-bit processing and delivered excellent performance. As you see on the charts here, this is also a very good training machine, particularly for workloads like fine-tuning. Now, all of this performance translates into true economic value. When you look at metrics like cost to serve 1 million tokens, this is actually an example from a recent Inference Max benchmark that was conducted. The latest GPUs, MI355, on the GPT OSS model, deliver up to 10x benefits in terms of the cost to serve tokens relative to our previous generation of GPUs. Now, this is exactly the type of economic value and gains that our customers expect generation over generation. And as our platforms have made progress and expanded in their capabilities, so have the workloads that have run on them. As you might remember, our initial focus had been on inference that leveraged the strengths of the MI300's memory system, with GPT being one of the early models. But since that time, inference deployments have expanded in terms of workloads. We have added recommendation system support. There are multiple modalities that are supported, and coding agents that are supported. So a number of inference models and workloads have now come onto the platform. We've also steadily expanded our training engagements. Many customers, Microsoft is doing MOE training on it, Meta is doing recommendation training on it. Our own teams are building European language models, and many exciting startups like Essential, like Cohere, like Zifra, they're all training their next generation model architectures on AMD platforms. Just to give you a sense for how the customer journey has been in terms of workload expansion, I want to tell you about what happened with one hyperscaler engagement. They started obviously with the first workload, very successful, and just within 12 months, within 1 year, they now have over 70 workloads spanning all of what I talked about that is now running on Instinct platforms. We're super thrilled that they're able to do these sorts of things. Now, as much as all of this adoption has been because of our compelling roadmaps, it's also been because of the tremendous gains that we have made building our software capabilities. So I want to talk a little bit about that. So if you look at ROCm, with each release, as we have added significant features and performance, that's what has been crucial to supporting all these workloads. We've also recognized that we needed to be relentless in our focus towards developers, improving out-of-the-box capabilities, providing more richer collateral, content, documentation that makes them productive right away. Our customers are actually delivering AI capabilities at unprecedented pace. We responded to that. We've accelerated our release cadence. New optimizations, new capabilities now ship every 2 weeks in Dockers and prepackaged containers. We've ensured that the leading models are supported on day 0. When DeepSeek came, or GPT OSS came, or the latest Qwen or Gemma models came, they all ran in day 0 in the last several months. So adoption of the platform, because of all of these improvements that we have made, has been growing significantly. And that momentum is showing in the numbers. 2 million models that exist on Hugging Face today all run AMD GPU platforms successfully. The top 10 AI frameworks and projects for GPUs all have very good AMD GPU support. And if you look at metrics like downloads, they are on a fast exponential. Compared to last year, we have 10x the amount of downloads. There is a growing and vibrant ROCm ecosystem. And we are doubling down on developers and the developer community even further to make it go even faster. Through collaborations that we have set up with research professors at Stanford and at Berkeley, through rich educational content that we're delivering in partnership with organizations like Deep Learning. We've also stepped up our engagement with the developers with a number of forums like hackathons, contests, and meetups, and so on. If you see in the last year, we have significantly stepped that up. An outstanding request that our developers have had is, hey, can I go to a place where I can go hack on AMD GPUs? And so we provided, in June this year, a developer cloud. It's been very successful, and we are committed to expanding that even further. Now, all of this progress, obviously, is not happening as an accident. It's because we are driving a clear and deliberate strategy. This strategy is actually pretty simple. It's based on two core principles: build with open source and build with the right levels of abstraction. So let me talk about both of them. When I talk about building with open source is where we have scale, and it also moves extremely fast. And that's where AI developers live today. And that's why we have chosen to do a lot of what we do in ROCm in the open. Pretty much our libraries, our framework codes, it's all out in the open, allowing people, customers and developers to contribute to ROCm. So that's been a big plus for us. We also leverage the trend towards rising abstractions. Let me give you an example of what I mean by that. I'm a computer science guy. I have a PhD in computer engineering. If you give me one of our chip that has like 100 billion transistors and said, hey, write some assembly code, it's very, very painful to do that. Engineers don't like doing that. That's what has led to programming abstractions like PyTorch, right? People like to write higher level code and makes them more productive. So that's what we have done. We have enabled very strong support for all these frameworks that are at the right levels of abstraction. That is the trend that is going to happen. The happy byproduct of that trend is once such code exists, is nicely portable across platforms, and we are benefiting from that. But the thing that I'm really excited about our software strategy is actually what's coming next. Over the past several months, many times my engineers have come and told me that, hey, we've used AI to write this GPU kernel, and it's shockingly better than anything that we were able to create before. So what is really happening is the enormous gains that AI has provided to general purpose programming is now coming to GPUs. While it's not yet fully there today, I am deeply, deeply convinced that a significant amount of GPU programming is going to be transformed by AI. A lot of GPU programming will be done by AI. And it will take down with it any last remaining barriers for the adoption of our platforms. So now, as we've made a lot of progress with our platforms, with our software, we have learned a lot from our customers about how their workloads are evolving, about their roadmaps. We have literally earned a seat at the table as they are designing and planning their next generation systems. And we have incorporated those learnings, those precious insights, into creating our best GPU family, the MI400 series. This is a defining moment in our AI roadmap journey. Built on top of the latest in process technology, it leverages all of our innovations that Mark talked about with chiplet architecture and 3.5D packaging. The MI455X product in this family packs up to 40 petaflops of peak FP4 compute. It has 432 gigabytes of HBM memory running at 19.6 terabytes per second. It is the best and most advanced AI accelerator that we have ever built, designed to serve trillion parameters models that are the reason the next generation of AI infrastructure is getting built. We've also synthesized all we have learned about our hardware, about our software, about our networking, and about how we bring it all together into a rack scale infrastructure with our Helios offering, which Forrest is going to unpack after me. This rack scale architecture is designed to service the most demanding training and inference workloads. With its leadership memory system, strong compute performance, and rack scale architecture, this product is designed to offer leadership performance and true TCO value proposition, truly differentiated TCO value proposition for our customers. Now, the MI400 series is more than the MI455 product. Even as AI has continued to transform markets, there has been a huge explosion in demand for scientific computing, driven by nations seeking self-sufficiency in their compute, and also research institutions and enterprises that want to make scientific breakthroughs. To address this exact need, we have built the MI430 product. So what the MI430 product is actually built out of the exact same hardware and software foundation of the entire MI400 series. It leverages our chiplet architecture, but it customizes the compute for what these markets need and provides the high precision, double precision floating point compute that is required for getting the highest performance for these markets. This product continues the leadership tradition that we have. We have the fastest supercomputers today with Frontier and El Capitan, and the 430 series is designed to continue that into future supercomputers. You can stay tuned for more around this project. We're going to share a lot around this product. We're going to share a lot more about this at the upcoming supercomputing show next week. So now, the MI400 series, our customers love it, right? Whether it's frontier builders like OpenAI or Meta, or infrastructure partners like Oracle, or research institutions like Oak Ridge. There's been significant interest and strong adoption for these platforms. Lisa talked a little bit about our engagements. I want to give you my own perspective, how this has gone. Let's start with OpenAI. A couple of years ago, when we first engaged with OpenAI, it was not clear how their workloads were actually going to get mapped to AMD GPUs. So we decided, and we sat with Don and said, hey, it's super important that we actually support Triton, which is a chosen framework that they use, and say we need to add AMD backend support for that. So we enabled it functionally, and over the last year, we made it performant with adding a lot more features and capabilities. And as they gained more confidence, they have expanded their engagement with us from hardware, from software, from networking, and that led up to the MI400 series. So we're super excited to see what they would be creating with this product. We're also deeply grateful for our engagement with Meta, starting with our MI300 series with Llama, where they served and showed that it's great for that reason, and expanding that to recommendation models. We've collaborated with them very actively with PyTorch, and deep collaboration with Helios that Forrest is going to talk about. When AI leaders that are defining the future of compute choose AMD, it absolutely validates our roadmap, our ability to execute, and to be able to be deployed at scale. Now, as amazing as the MI400 is, what seems to be even more extraordinary is the demand for compute keeps going up. As models become larger, as models become stronger, as they become more diverse, they become agentic, they think, they interact. As industries adopt them more, there is continued need for a lot more compute. And to meet this extraordinary demand for compute, we are introducing our next big leap, which is the MI500 series. With significant innovations in compute, memory, networking, rack scale integration, and even deeper hardware and software co-design, this is not an incremental step on our roadmap. This is going to be our next big breakthrough in AI performance. So now, to bring it all to a close here, we are at a truly unique moment in our AI journey. Our leadership roadmaps are getting stronger, delivering greater gains with each generation, expanding our usage. Our open platforms with our rack scale systems and open source software are driving greater adoption. The deep partnerships that we have set up with the AI leaders that are defining the future of computing are showing what is possible when you collaborate at scale. And the MI400 series is poised to place AMD in the middle of some of the largest AI infrastructure build-outs that will define this decade. Together with our partners and customers, we are thrilled to be able to build the future of compute. Thank you. And with that, let me welcome Forrest back to the stage to tell you how it's all going to be put back together at the data center level.
Thank you, Vamsi. Well, as Dan and Vamsi showed you, we are committed to driving leadership in the CPU, GPU components, and in, again, the software that makes them sing. Now I want to talk to you about how we put it all together with the networking and, of course, with the system design at the rack and cluster level to truly build complete AI factories. Let me begin with networking. And networking, as much as GPU and CPU now drives the performance of AI factories, the amount of data that has to be moved around to feed AI, to act on the results from LLM engines is absolutely incredible. And you have to have the networks that can handle it. And the networks needed for an AI factory have rapidly evolved. From the old days of a single network, we now see that you have to have a front-end network and up to 3 back-end networks to effectively scale out the GPU systems to reach gigascale. And our approach to providing these networking solutions is a little bit different from our competitors. First off, we believe in open. AMD always has. We believe in open standards. We believe in open ecosystems. And so at AMD, we've been thrilled to help spearhead some of the most significant new networking standards over the last few years with the Ultra Accelerator Link and, of course, with Ultra Ethernet. Ultra Ethernet is a great example of a standard that has rapidly made Ethernet the premier, unquestioned best scale-out fabric in the industry. And we've done this in conjunction with other leaders in the industry. And so offering our customers choice and enabling others in the ecosystem to add incremental value to the AMD open ecosystem of AI systems. Well, let's begin diving deeper with the front-end network. And the front-end network is an underappreciated part of the puzzle, but in reality, without the front-end network, the user can't reach the LLM. The LLM or the AI agent it cannot reach the data, the databases, the resources that it needs to actually turn tensor operations into intelligence. And a good front-end network can do more than just connect. It can actually add performance to the overall system to accelerate AI and cloud workloads by offloading key tasks, software-defined networking, storage access, storage abstraction, and of course security. And security, as Mark mentioned earlier, is incredibly important in the era of AI, and networking can play a huge role in ensuring that systems are secure end-to-end, such that users' data and the AI models are always protected. At AMD, we have a fantastic solution for front-end networks. The Pensando team at AMD has built the world's best DPU. We're now on the 4th generation of this processor. It has a unique architecture using P4 programmable engines that allow us to do stateful and stateless services of any nature for traditional SDN and security offloads, but also to provide services to offload specific data movement actions for the GPUs. And it does all of that at line rate performance. So with the Pensando approach for both the front end as well as I'll describe the back end networks, you can actually deliver network innovation, continuously evolving at the speed of AI without giving up performance. Now, in the back-end networks, I mentioned there's 3, and there's 3 that we are talking about today. You have the scale-up network that takes pods of GPUs, dozens to a few hundreds today, and welds them together into effectively a logical GPU that can coherently share memory and results in a very efficient fashion and look like a large resource, large single GPU resource. You also have the scale-out network that is not as tightly connected, but allows you to efficiently scale, particularly for training, out over hundreds of thousands of GPUs. Now, the new concept, candidly, over the last year or so, is the concept of scale across, where even scaling out to 100,000 GPUs is not enough. To reach gigascale, you have to bust out of the walls of a single data center hall and federate data centers or data center halls in an efficient, effective way. For scaling up, that welding together of dozens to hundreds of GPUs, what really matters is you have to have an ultra-low latency connection, you have to have ultra-high bandwidth, and you have to adhere to the data transfer protocols that GPUs want to talk. You don't want to put any friction in translating from the way that GPUs compute and want to communicate into the protocol that you're using to do so. And of course, you have to have not just a scalable technology to bring out to hundreds or thousands. Above all else, you have to have reliability, because you can't have a link flap or a single link going down bring down your entire pod of GPU, perhaps ruining hours of training time or disrupting a critical distributed inferencing task. At AMD, with the MI450 and with Helios, our solution to scale up is open. We are implementing the Ultra Accelerator Link protocol that efficiently provides load store semantics to the GPUs to allow them to efficiently communicate. We are transporting that protocol at 260 terabytes a second across a Helios pod of 72 GPUs via packetized Ethernet, ULEOE. It's very similar in concept to the emerging standard ESUN, where we're trying to packetize various protocols using Ethernet to transport. And in Helios, we then have the scale-up fabric linking all of the GPUs together over 6 redundant network planes to, again, provide that not just bandwidth and performance, but resiliency to ensure that a slight perturbation in the network doesn't bring down the pod. For scale out, we connect, again, hundreds of thousands of GPUs to work as one. This is an area where the industry really has innovated together with Ultra Ethernet and with similar efforts to efficiently provide advanced RDMA networks that improve performance and, very critically, reliability over either InfiniBand or Rocky V2. But more than this, the AMD Pensando NICs that we use to connect to the scale-out networks with their P4 programmability offer us additional opportunities to accelerate performance, to offload communication tasks from the GPUs, to offload collective tasks from the GPUs, to improve compute resource utilization and therefore get workload acceleration. They also allow us to innovate new features like multi-plane support and advanced packet transport handling to further improve network TCO. We've seen the multi-plane support offering opportunities to reduce the scale-out networking TCO by 50%. And then, of course, there's scaling across. Now, this is where things get a little bit different. If you're scaling across to multiple data halls or across tens of kilometers, the latency and reliability of those connections is different, very different from within the data hall. And so the network has to be able to accommodate dramatically varying latencies and network perturbations. So you have to do adaptive path management. You have to do dynamic load balancing. And there's a variety of approaches that have been recently promoted to do this. At AMD, we think the intelligence to do this really is where the data is generated and consumed in the node itself. And so we have implemented scale across and begun delivering it to our customers already with the existing Polara 400 NICs for MI300s in the NIC itself, and we can effectively deliver scale across functionality and performance without relying on proprietary or expensive switch extensions. And so the NICs that we have to provide these scale out and scale across features are our Pensando Polara 400 and Vulcano NICs for the MI300 series and the MI400 series. But true to our commitment to open, we also support customers to have choice. And so we support, amongst others, Broadcom NICs as well. So the Thor series of NICs work very well with AMD GPU solutions. The Thor 2 with the MI300 series, and forthcoming, the Thor Ultra series of NICs, which fully implement UEC, also work extraordinarily well inside of Helios. And so our system is not closed. So let's put it all together. Scale across means multiple data centers can be confederated together. Scale out means you can combine hundreds of thousands of GPUs together using advanced Ethernet. And then diving into the rack, as Mark showed earlier, we're using UAL and Infinity Fabric to interconnect the CPUs, GPUs, and scale out NICs within the compute blades. And then we have Ethernet-based scale-up switch trays that take the UALOE traffic and switch them with very low latency, high performance Ethernet-based switches. Those are interconnected via redundant cable cartridges that have short lengths and provide high reliability redundant connections interconnecting all of the switches and the CPU compute trays. Finally, the front-end network and the scale-out network emerge from the Polara or Thor NICs and interconnect to the rest of the data center systems. You put it all together and you get Helios, which, as Vamsi said, we believe will be the most performant, most efficient, most serviceable AI factory building block when it comes to the market in Q3 of next year, incorporating all of our technology and doing so in an open way. But just as we will continue on annual cadence for the components, we will continue evolving our rack level systems on an annual cadence as well. And so accompanying the MI500, we have the yet to be name revealed rack that we'll unpack more later, but again, it will offer more. It will offer more GPUs, more bandwidth, more capability, more performance, and the next generation of our components. So stay tuned on that. Important to understand, for both of these, AMD is not selling the rack systems. We are developing the complete solutions ourselves and in conjunction with our partners, and then bringing them to market through leading OEMs, through our ZT partners who are now owned by Sanmina Corporation, and of course through our other ODM partners across the ecosystem. And so they will all have time-to-market solutions for MI450 when we bring it and Helios to the market. And so let me end where I began. You know, we set out a decade ago to drive data center leadership. We've made tremendous progress on the CPU side. We've made tremendous starting progress on the GPU and the networking side. But with the capabilities and the teams that we have in place, with our strategy and our partnerships, we are highly confident that we can build the best AI solutions for the AI factories of the future out for this foreseeable future. And when we think about the $1 trillion TAM for AMD, which is, by the way, that's a silicon TAM, just so we're clear. That's not to be compared to some others that might talk about an overall solution TAM. But the $1 trillion silicon TAM, we're very confident in our ability to address it. We've already grown the AMD data center business from essentially zero when we began this journey 11 years ago to over $16 billion expected for this year. That's a great growth. But we believe with our portfolio that growth can accelerate. And as Lisa already mentioned earlier, we believe that we have clear line of sight to 60% CAGR over the next 3 to 5 years for the AMD data center business writ large, which generates, you can do the math, over $100 billion in annual AMD data center revenue. It's an incredibly exciting time for our whole team, and we are so pleased to be part of this journey. Thank you very much. Let me now turn it over to Matt, who's going to take us to the break. Thank you, Matt.
All right, thank you, everybody. Hopefully that was an informative session. We are going to take a break. We were running just a hair behind. I think Jack is going to come on and talk about our client and gaming businesses. We are going to do that at 3:30. So it'll be a little bit of a 5-minute delay from what we had put in the agenda, but we wanted to give you guys time to get through the restroom queues and all that fun stuff. So back on here at 3:30, and thank you very much.
All right, that was pretty awesome there. I think something that just kept coming along. I mean, something they kept reiterating during the event. Looks like they are gonna restart again in just a little bit. The stock did initially pop up to 240. How about 240? Right up here, about 240, almost $247 a share. But then it went back down. It looks like they're taking a quick break and they'll be back. Something that they kept referencing is by the way, they're going to be talking about their gaming sector. Their gaming sector has really grown over 100% this last quarter, Q3. And it's going to be really good to see how they are integrating in the gaming sector and how they're playing there, because they were losing customers. The revenue was going down, but it looks like the revenue is finally coming up in the gaming. Something they kept bringing up is AI on edge. I was looking at a stock yesterday where AMD, they specifically focus on AI on the edge. So these are things like Internet of Things, watches, connecting AI to your watch to where it doesn't just disappear. It doesn't run out of batteries very quickly. And so I went to Google. I went on Google and I kind of wanted to bring up some companies that are focused in this kind of area. Obviously, you know, the larger institutions like Amazon, Intel, Microsoft, they all have their own AI on edge. But there are smaller companies, I think, that are innovating new products specifically for AI on edge. And so I wanted to look at a couple of those. And I think, I don't know from which one from the watch list that we've been creating here, one of these companies did focus on AI on edge, but I don't remember which one specifically. It might be this, maybe. Semiconductor system, intellectual property solutions, rest of the China, United States, Europe, Flexio, nope, nothing AI on edge. Well, it was one of the companies, but I did go to Google here to get me the stocks. Under 70 $70 billion market cap and focus on AI on edge kind of business. So just a second here. So here you go, under $30 billion. So you got One Stop Systems. I've been looking at this company for a while. They actually are having a really good year. So if we kind of zoom out a little bit, they've had a really good year here, up 62%, almost 63 year to date. In 1 year, they're up 124%. So there's definitely business in the AI on edge, and it looks like one of the leading AI companies is looking for more business in this type of industry. So in the last month, this one specifically, One Stop Systems, is they've been doing well year to date, but like maybe in the past month they're down about almost 8%. past 5 days down 6.27%, and today they're obviously doing quite well. Let me see if I can go to their website here. Website. Web. We can look at some of the products here. One-Stop Systems. So One-Stop System designs and manufactures innovative edge computing modules and systems for many applications, including ruggedized services, compute accelerators, expansion system, flash storage, array, and so on and so forth. So as you can see, the capabilities, defense, commercial, and domain, such as space. But if we look at this specifically, a lot of the AI at edge is around like the watch, what you can do with your phone, what you can do with different types of gadgets that people wear. In use case, rugged AI computing, sensors, autonomous navigation. If you think about like the glasses that people wear, the Meta glasses, as well as the Meta Quest. Those type of products often use a very large battery, and the AI at Edge kind of says, how can we make these items, these products, have the capability to have AI, but also have the batteries last like a very long time. You got rugged GPUs, flash storage. So rugged detector class mission critical systems are needed at the point of data collection to process these large data and make AI-driven decisions. So if you think about a company like Anduril that are making these jets that can fly independently and make their own decisions on altitude, how can you kind of create an AI on the edge product so that the products that are put within the system have enough battery to stay in the air for a long time? Sensors and fusion signal processing. The OSS mission critical systems transform raw sensor data into actionable intelligence driven innovation and unlock new dimension of performance. Stuff in your car, obviously, how do you make AI products in the car and have them work? Data acquisition and transport. AI is a core component of deploying truly autonomous vehicle in commercial, industrial, and defense applications. AI inference. So this is where AMD kind of plays a role. We deploy rugged edge servers and rugged embedded compute to resolving large-scale AI inference in military and commercial vehicle applications. Our innovative edge compute platform utilizes hardware across entire performance spectrum for enterprise class to embedded CPU, GPU, I/O, along with PCIe-based scale-out expansion of high-speed, low-latency switch fabrics to support one or many simulations AI inference applications. High-speed fabrication. One of the things is the glasses. I think that's where it's going to be huge here. How do people use these glasses that they, in the VR world, make video games along with them and allow people to play these video games in a very low latency manner? I'm going to keep this site. One-Stop Systems is one company, and I think I just lost my research. We got Brian Chip Holding. I've never heard of this company here. Let me refresh this and go down to research. Let's see what this company does here. It's called Brian Chip Holding, Mobileye Global, One Stop System, UiPath. I used to own that company. Sentinel is another great company, but they're more of like AI and security. SoundHound, I have no idea how SoundHound plays a role there. Brian Chip Holding, once again, very small company here. 300, how about less than $500 million market cap? So it is right at the edge of small cap. Performance-wise, 1 year, down 35% year to date, down almost 60. Okay, why is this company not doing so? Semiconductor stocks are lagging while the rest of the market is mostly high. Now this company is not having a good performance here. Let's see why. Let's look at their products. On-device edge AI, 100x more efficiency, run real-time AI on milliwatts of power. So they have their own technology that they license, accelerate hardware design combined with state-of-the-art development tools and advanced neural network models to bring OneDrive intelligence to a chip design. Yeah, so practically a lot of this AI at the edge is how do you make a product last a long time, and how do you also kind of save power, or they don't use too much power? Why one device AI matters. Cost efficiency, low latency, reliability, privacy, security, and personalization. They have this thing called Akida Edge AI IP platform. Everything you need to build on device. So these are the products that they have. So they have this IKEA AI Accelerator Processor IP, IKEA Development Tool, ready to use IKEA Natural Network Models, and IKEA AI Accelerator chips. So these are all different ways they can make revenue. I like companies when they have multiple ways that they can make revenues. So customers, looks like they got NASA, Renaissance, they got Benz, Mercedes-Benz, Mega Chips, partners. Those are their customers. Their partners are most likely so they have RTX, Global Foundation. I've never heard of the rest of the other companies, so probably their partnership isn't as deep as other like one-stop systems. Let's look at their investor presentation real quick to see how that looks. Investor updates. So announce products and solutions with key ecosystem partners in IKEA technology. So it looks like this is something they created with partnership of creating some kind of glasses that have AI at the edge, AI on edge application, breakthrough AI powered wearables, predicting. So this is the same thing as like the Facebook glasses. RTX for radar contract, okay. And then they have Akida Front Grade launches new grain line to augment processing space with neuromorphic AI. Okay, drones, AI-powered events based on vision solution. Okay. Market reach, TAM, SAM, Kaigar, strategy, execution, overall edge compute, but it looks like they're saying that it's 19 to 16 billion dollar growth of about 24% Kaigar between the next 7 years. Silicon making up 8 to 54 billion, and then software. So the cool part is they do have both software and hardware solutions here. Strong market growth for Edge AI. Asia Pacific Edge AI market 2025, and they're expecting this to grow about 26.1% Pacific market Kaigar in the next 7 years. High neuromorphic growth in key metrics. Mobile and customers. Automotive, so these are the areas that they think is going to be there. I think I can see like the glasses actually working in the medical field, where doctors are doing something and they look through the glasses and take certain actions, as well as your phone, your watch, vehicle, defense, aerospace. So about 46% of it is going to be mobile and consumer. I think I do agree with that. By 2034. By 2029, they're saying 48% is going to be mobile and consumer. And by 2024, which would pass, they're saying 84%. New market development and Edge AI. LLM market is cloud-based, but is expected to be deployed on Edge in the future. So this would be a little bit more good to understand where we're going, because cloud compute is a thing right now, and it's actually kind of expensive because you have to send data to the cloud and then get that data back. And how is that going to look versus having that data right on your phone and synced right there, and so that you're able to your phone or your product is able to react to situations right away. So LLM market is cloud-based, but it is expected to move to Edge AI. So currently, almost everything we see out there is running on a cloud-based system. So ChatGPT, Claude, Gemini run in the cloud because massive compute requirements, centralized control, and scalability. Future trends are going to be edge deployment. LLMs are increasingly being optimized for on-device or edge platform. With edge, you get low latency because the system is built within the phone, within the product. Real-time response, especially when you're playing a video game or when you're building a virtual world, AR, VR, glasses, robotics. This makes for the system to react a lot faster and doesn't have to wait for some kind of system to respond. You got the privacy as well. So sensitive data systems are local within that product and not in the cloud. So imagine you can have AI without any data, and you're able to search on your phone. Like let's say you can use Google without any internet. It's almost like that. Offline capabilities enabling functionality in remote areas during a network outage, useful for defense, field operation, and rural deployment. And this is once again, military is for the military is going to play AI on the edge is going to be very, very important, because, and if you think about it, like even in space, or let's say we send something to Mars, we want AI to play a role to where we don't have to send any signals to space. We want the AI to make decisions based on all the training and the capabilities that it's been able to learn while it was here on Earth. and it says cost efficient, so reducing cloud infrastructure costs at scale, and then ideal for consumer devices like smartphones, wearables, and Internet of Things sensors. There's a lot of companies that are out there actually building out.
Please return to your seats. The program will continue soon.
Okay, you got 3 minutes. There's a lot of companies out there building out the hardware for this type of AI at edge, and one will be like Helium Crypto. So this is Helium Mobile is actually a company that's kind of building that platform right here for AI on edge, for Internet of Things, where devices can speak to one another using products that are involved in AI on edge. Low latency, so hybrid architecture, embedding. So many companies are exploring hybrid models, edge for inference, cloud for training and fine-tuning. Federated learning models learn across devices without centralized data. So this is where AMD is trying to compete, and they're trying to partner up and make devices that will support this kind of infrastructure. But it looks like they're about to begin, so I will go back to this so we can listen to it and we can see the stock and see how it is doing. AMD. So let's get started here. It looks like it's down. The market is taking them down despite really announcing amazing partnerships, amazing growth as well.
Resuming now. Please welcome back to the stage, Matt Ramsey.
Thank you very much, everybody. Maybe we'll just, I think there's some people over here still finding their seats, so we'll just give it a couple seconds. I have no other entertainment to offer, so I apologize. Anyway, thank you, everybody, for following instructions and getting back to your seats so we can start close to on time. Hopefully you enjoyed the first few sessions around Lisa, Mark, and the data center guys. I think as we move forward here, I'm really excited to welcome to the stage our head of our compute and graphics business, Jack Hune. He's been running that business for about 2 years, and I think you guys might have noticed a difference in the results of that business in the 2 years he's been running it. So come on stage, my friend. Lots of good stuff to talk about. Thank you, Jack.
Good afternoon. It's great to be here in New York to share how AIM's compute and graphics business is evolving and to share with you where we're headed next. As Matt and Lisa said, I stepped into this role 2 years ago, and we unified the client and gaming organization into one business. Today, I'm going to share the momentum and, more importantly, the path we're on towards market leadership. And I can't think of a better way to share my excitement for this business than to be here today. We have transformed the business in the past 2 years, and we achieved our market growth through a leadership product portfolio. And we deepen our relationships across the entire ecosystem, from OEMs to software developers. we've also accelerated our time to market and drove R&D synergies across our client and gaming organizations. And this strategy delivered 50% year-on-year increase in revenue from $9.6 billion to over $14 billion in just this past year. And it all starts with building a great product portfolio. We have built perhaps the best desktop portfolio in the industry with our X3D technology. We also have the top-selling gaming CPUs. And in mobile, we have the best AI PC portfolio top to bottom. In enterprise, we are accelerating our commercial share growth. We have the world's best workstation platform with Threadripper. And early this year, we added Dell as a new enterprise partner with a top-to-bottom AI PC portfolio. And we have a partner-first mindset. We design and bring the right products at the right time. And we align our roadmap with our customers' long-term, multi-year strategic needs. And we're building a world-class go-to-market operations to further scale the business. And there's no one better to tell our story than our end customers. And the response has been very strong. Large enterprises are converting to AMD for the very first time and seeing the benefits. Over 50% of Fortune 100 companies have already deployed Ryzen PCs. And we've also expanded our footprint into the public sector. I'm very pleased with the incredible results we have been able to deliver. We have a systematic and strategic approach towards business growth. We have doubled the business in just 2 years. And we've been able to change the economics of client from value to premium, growing our ASPs 50% in the past 2 years as well. At the same time, we've almost doubled our market share while growing our ASPs to a record 28% revenue share. I love client, but I'm also a lifelong gamer, and I'm incredibly proud to win consecutive generations of consoles with Microsoft Xbox and Sony PlayStation, which is unprecedented in the industry. We also created a new category of AAA gaming handhelds, enabled the entire catalog of PC games to be accessible on a handheld device, driving a new vector of growth for our gaming business. In consumer graphics, we focus our strategy on delivering the best mainstream GPUs in the marketplace, offering the best performance per dollar. And our graphics architecture is highly scalable. It allows us to address a large range of segments in both client and gaming. And we're working very closely with our software developers to reduce the time of development of all future games, creating massive new worlds with more immersion, more detail, and more exploration. And we're ready for this transition. All this growth we just talked about is still in the early innings of the AI PC acceleration, but we're building towards something even bigger. We're entering a new era where AI is happening everywhere, running directly on the devices that you use every single day. Over the next several years, we expect to see over 1 billion end-user devices powered by AI locally, which is why we're infusing AI into everything we do across client devices, gaming, and broader compute solutions. And we have the scale to drive the AI PC inflection to the market with the right partners and the right platforms. We believe that AI will fundamentally augment the value that the PC can deliver. You have thousands of interactions with your PC every single day, and AI will be able to understand every personal interaction, bring automation, deep reasoning, and personal customization to everyone. What AI did to the cloud with large-scale design automation, AI will bring to the endpoint with low-latency task and productivity automation. In the education space, AI has the potential to be a personal tutor for every student, an assistant for every teacher. The learning process is highly personalized, and AI will be able to adjust for every individual. Let me show an example of how fast the AI ecosystem is moving. Just 18 months ago, Llama 3 model was introduced, amazing the world with its AI capabilities. At over 70 billion parameters, it was a model that could only be run in the cloud. Fast forward to just a few months ago, and similar models can now run locally, more efficient, just as performant, and just as accurate as the bigger models. This fundamental trend is going to change and continue and will only accelerate the AI PC value. We have a very aggressive strategy and a very ambitious roadmap. Our AI PC strategy starts first with building a great PC, a better PC, the perfect PC. And then we add the best AI architecture and capability to it. We have a no-compromise PC strategy. And we're investing ahead of the curve to capitalize on the AI PC value creation, to lead the industry through innovation. The future of AI PCs will be built on AMD. And we're aggressively accelerating our client and gaming with an AI-first mindset, but it doesn't stop at the endpoint. We see AI expanding beyond the endpoint, and the same problem statement we're solving for endpoints also exists at the edge. The explosion of data by endpoints creates demand for AI at the edge. Besides the need for confidential individual AI assistants, there's a need for confidential enterprise-level AI assistants. This is where edge AI can provide capabilities to deal with the large amounts of data produced by endpoints and extract decision-making ability at the enterprise level. For every scale of model, there's an optimal hardware to process it. And we release products spanning tens of billions to hundreds of billions of parameters models. We create a new product category with Ryzen AI Max, a mobile AI workstation with 120 gigabytes of unified memory across the CPU and GPU with full CPU and GPU coherency. It also doubles as a supercharged small form factor AI device supporting up to 128 billion parameter models. We also recently launched our new and first Radeon AI Pro inferencing cards designed for scalable multi-GPU deployment, and it's a very cost-effective solution for large AI models available today. We also leverage our ROCm ecosystem from endpoint to cloud to provide a seamless developer experience. And we're deepening our R&D investment to go after this opportunity as we expand our AI portfolio. The opportunity in client and gaming has never been greater. We have a very consistent strategy, as Lisa outlined earlier today, building great products, leading the ecosystem, driving operational efficiency. Our focus is to strengthen AMD's market leadership and drive sustained growth. We have a strong leadership roadmap, a deep ecosystem partnerships, and a proven track record of execution. And we're confident in achieving revenue growth at more than 3 times the market rate while expanding our market share to over 40% in the next 3 to 5 years. We've built tremendous momentum, and we have a clear path to market leadership. Now we're entering a new era. AI is transforming the PC experience and redefining what compute means across every device in our portfolio. This is not just another product cycle. It's a once-in-a-generation shift towards expanding our opportunity across every segment. Our next chapter is about scaling the client business, deepening our console advantage, and unlocking new growth with AI at the edge. If I can leave you with one thought today, it's we are ready to lead the gaming and AI PC era. Thank you. And with that, let me introduce my colleague, Salil Rajay. Thank you, Salil.
Let's talk AMD Embedded. What's happening inside AMD Embedded is one of the biggest transformations at AMD. I bet most of you haven't been thinking much about the AMD Xilinx acquisition since it closed in 2022. But it still stands as the largest and, dare I say, the best managed acquisitions in semiconductor history. I'm both honored and humbled by the response of taking that historic business and turning it into long-term value for AMD and for the customers we serve. We come a long ways. Let me share with you what we've been up to and where we're headed next. The scope of AMD Embedded has increased tremendously over the last 3 years. What Xilinx brought to AMD was leadership FPGAs, adaptive SoCs, a whole host of strategic IP, AI engines, high-speed interfaces, but just as important, thousands of loyal embedded customers. AMD delivered high-performance compute IP, CPUs, GPUs, APUs, plus scale, manufacturing depth, and advanced packaging technology. We are now leveraging the strengths of both companies to deliver integrated end-to-end solutions for our customers. We are unlocking new vectors of growth and winning designs that neither company could have won alone. Since the acquisition, we expanded the scope of embedded significantly. We increased our portfolio to go now from cost-optimized products to high-performance versatile-class products. But the embedded business has been increased beyond FPGAs to now include embedded x86, where we leverage CPUs, APUs, GPUs, to semi-custom silicon, where we are focused on strategic customers for their high-value engagements, to physical AI, as cloud intelligence moves to the physical world, to the real world. And this is allowing us to tap into $30 billion of TAM. We're continuing to win in our core FPGA business, the adaptive compute business, at the same time expanding into new spaces, leveraging AMD's IP portfolio and global reach. Prior to acquisition, our portfolio was narrow. On the adaptive side, we focus mostly on high-end FPGAs. Our portfolio in the embedded x86 space was also quite narrow. That meant we had clear gaps in key markets. That limited our reach and constrained our growth. But since the acquisition, we expanded our portfolio significantly. On the adaptive side, we now go from cost-optimized Spartan-class products to high-end versatile-class products. And that has allowed us to go after markets such as vision, robotics, and all the way to aerospace and defense. And this is also enabling us to grow at a rate faster than the baseline FPGA growth. On the embedded CPU side, we've taken AMD's dormant CPU business and created a more compelling and competitive product portfolio. And now that's allowing us to go after markets such as industrial, networking, and storage. We have launched 40 new products and now winning designs and building the foundation for semi-custom silicon and physical AI. This is the strongest and broadest and most competitive portfolio that we have ever had, and a strategy that is working. Across FPGAs and embedded x86, our design momentum is exceptional. We're continuing to double down on adaptive compute, still our crown jewels. now broader, stronger, and more competitive than ever. On the embedded x86 side, we have a highly leveraged, purpose-built product portfolio. And that is allowing us to go after newer markets, newer applications, new customers. Our embedded sales team and our channel partner organization have deep relationships with thousands of customers. We are now taking that broad portfolio of products and working with these customers and winning market share across all our markets. And that is synergy that is paying off. Our design win momentum is phenomenal. We won thousands of designs totaling $36 billion plus. And that is execution, that's customer trust, and that's how winning in embedded compute. As Lisa mentioned, and Mark also talked about, AMD Embedded is now in the semi-custom silicon business. Semi-custom silicon business will be one of the largest growth vectors for AMD Embedded, and is accelerating fast. We are not just going after every ASIC. We are very focused on a few strategic customers with high-value engagements, where these customers are co-developing with us because of our application knowledge, our IP, and our execution. We are leveraging the industry's broadest IP portfolio. Our FPGAs, our x86 CPUs, ARM SoCs, GPUs, APUs, NPUs, DPUs, RF technology, and our advanced packaging technology. Our financial strength and our scale is allowing our customers to put their entire roadmaps onto our platform. And that's really the killer combo that is allowing our customers to be anchored to us for their mission-critical multi-generational products. We have secured a significant number of design wins through semi-custom silicon business. $15 billion across automotive, data center, aerospace defense, and wireless. In the years to come, semi-custom silicon business will add meaningful revenue to AMD Embedded, scaling up to almost a third of our business over the long-term horizon. Semi-custom silicon business is one of the clearest examples of how we are transformed from a focused FPGA business to creating a broad compute platform and having entirely new growth engines. Now, putting it all together across FPGAs, embedded x86, semi-custom silicon, our design win momentum has never been stronger. Prior to the acquisition, we grew our design wins at single digits. Since the acquisition, we have increased the pace and scale of our design wins and now growing to strong double digits. In 2024, our design wins was about $14 billion. This year, in 2025, we've already surpassed that record, and we are now scaling up to $16 billion. This design win momentum is a direct result of our execution, our broader product portfolio, but also, frankly, because we can now put end-to-end solutions in front of our customers. And this is a pipeline that's booked and now positions us well for meaningful revenue acceleration over the next 5 years and beyond. Speaking of revenue, last 2 years, our business was a bit soft. And the softness had to do with and inventory correction. Most of our customers were draining inventory through their entire supply chain. Now that phase is behind us, and growth is returning to our business. In the future, as part of AMD, our trajectory is completely different. In the near term, we'll grow our revenue at 2x the market rate, scaling up to 3x the market rate over the long-term horizon as semi-custom silicon and physical AI start to ramp. We're also tracking to 70% market share in our core FPGA business as we continue to extend our leadership and start gaining more and more market share in that business. So this is how AMD Embedded shows up in the P&L. Market share growth in the near term, and a clear path from revenue growth, 2x the market rate, to 3x the market rate over the long-term horizon. Everything I've covered so far, from product portfolio expansion to design win momentum to semi-custom silicon, is getting AMD Embedded ready for what's next. And what's next is physical AI. Physical AI will be the biggest transformative vectors for AMD Embedded. Intelligence will move from cloud to the physical world to the real world. Billions of intelligent systems will be deployed across all industries in applications such as autonomous driving, robotics, and drones over the next decade. These intelligent systems will perceive, decide, and act instantly. The physical AI market is expected to be $200 billion plus by 2035. AMD is uniquely positioned to win in this market and gain significant market share. We're already working with many of these customers in these applications. AMD devices are already used to power many of these applications in sensor fusion, in vision, in control logic. We are building upon this foundation for whatever form physical AI takes, because we intend to lead it. Unlike in cloud, which mostly focuses on inference and training, in physical AI, we have to optimize the entire pipeline, from perception to decision to actions, all happening in milliseconds. Safety, privacy, and real-time performance are important considerations in physical AI. AMD is the only one that can optimize across perception, decision, and action. Perception being sensor fusion, decision being low latency inference, and decision has to do with real-time processing. For sensor fusion, we have hardened sensor fusion IP for standards-based sensors. We have our adaptive fabric when customization is required. We have, for decisions, for low latency inference, we have either FPGAs or NPUs. When large models and big TOPS are required, we have our GPUs. For action, we have x86 CPUs, ARM SoCs for real-time processing under safety constraints. We can mix and match any of these IPs to create purpose-built products for each of the applications. The bottom line is, while our competition is mostly focused on inference and providing multi-chip solutions, AMD is the only one that can optimize across perception, decision, and action on a single embedded platform. I've covered a lot today, so if there's one takeaway I would want you to have, it's this. AMD Embedded has become a high-margin growth engine for AMD. We used to be a focused FPGA business. We are now a multi-dimensional powerhouse built upon adaptive compute, embedded x86, semi-custom silicon, and physical AI, each a growth engine on its own. Our momentum will make embedded a defining chapter in AMD's success story. Thank you. With that, I want to welcome our CFO, Jean Hu. Hey, Jean.
Thank you, Salil. It's great to see everyone. Thank you so much for joining us today. You have just heard from Lisa and the team our strategy, our technology product portfolio, and our focused execution, which is driving tremendous momentum across all our entire business. Now it's time to connect the dots to your financial model, and in particular, how all of this position us to address very large market opportunity ahead of us and our long-term financial model. Fundamentally, as a management team, we are here to build a compounding business model to drive revenue growth and significant earning per share expansion to create long-term value. So when you look at our financial framework for value creation, it has been consistently anchored on three core elements. First is about accelerating top-line revenue, targeting the most attractive market opportunities, driving technology and product leadership. Second is about delivering compelling profitability, expanding margins, and driving operating leverage. And the third, which is most important, as all of you know, is about disciplined capital allocation, not only to fund the growth for the future, but maximize returns for our shareholders and owners. So by laser focusing on these top three priorities, this management team has demonstrated a phenomenal track record of execution and value creation. I'll do a quick recap of the last decade, how this team has executed. First, on revenue. If you look at 2016, the company's revenue was only $4 billion. We have been able to drive significant revenue expansion to expected $34 billion with a CAGR of 26%. On profitability, what our team has done is compound the fast revenue growth pace by expanding gross margin. 2016, the company's gross margin was barely 31%, and we expand gross margin to 45% in 2020, and we expect to deliver gross margin of 54% this year. And of course, gross profit expand much faster than top-line revenue growth at 34% CAGR. This team also translated the operating leverage into our overall operating profit increase. If you look at the operating profit, in 2016, it was barely $43 million. And this year, we're expected to generate over $8 billion operating profit, which is 79% CAGR. So it has been tremendous how this team has executed financially. On capital allocation, Lisa talked about how we have invested over $100 billion through organic investment and acquisitions, and how those investments have positioned us for acceleration of our technology product leadership and also market leadership. This team is very, very focused on return on investment. On organic investment, first, we prioritize R&D investment. So if you look at our operating expense and CapEx, vast majority of investment is on R&D. We have a very rigorous internal resource allocation process each year. We examine the market opportunities, the assumptions we made on different investment. Every project gets examined and every investment gets examined. The team is not afraid of investing ahead of curve. You heard from Lisa, from Mark, how we establish innovation and long-term leadership. But it's also the case, I joined 3 years ago. I'm still impressed and amazed how team's discipline has been. Is if the assumptions we made were wrong, and if the project would not generate returns we estimated, they are also not afraid of killing the project. Really allocate the resources to the most important project which generate the highest return. And over time, Mark talked about how we build the foundation for the future technology leadership and how we shift resources to allocate to data center and AI. So on the acquisition side, we apply the same discipline. What we have done is not only focus on strategic acquisitions, they have to generate significant returns versus our alternative capital use, like organic investment or do buyback. That is really important for the team. A very good example is the recent acquisition of ZT Systems. We acquired the ZT design team. At the same time, we separated the ZT manufacturing operation and divested that business. So through both acquisition and the divestiture, not only we achieved our strategic objective, like Forrest said, accelerate time to market significantly for our MI450 generation product. More importantly, we generated significant cash for our shareholders through the divestiture. So Lisa mentioned we have built a tremendous execution machine and a playbook on acquisitions and the integration, so we can really deliver returns for our owners. When you look at the discipline, the capital allocation the team has done, it really drives significant business transformation and acceleration of our financial momentum. Lisa and Forrest talk about how we really transformed the business to data center, like $2 billion in 2020. Now it's over $16 billion, almost half our business. You know, for CFO, what's really most exciting? It has a higher gross margin. So structurally, we are focusing on the highest growth opportunity and the high gross margin. And then on financial momentum, we have accelerated our financial momentum. If you look at 2025, we expand the revenue growth by 32% based on our estimate for our Q4 guidance. And both client gaming business and the data center contributed to this increase in revenue. On gross profit, we expand the gross margin to 54%. And the second half of this year, we're ramping MI350 significantly, but we are able to continue to expand the gross margin. Primarily, it's driven by the newest generation product we're introducing across Ryzen, EPYC, and the Instinct family. So it's very exciting how we continue to drive the richer product mix across all our business. On operating income, we are leaning in, investing aggressively this year. We continue to deliver over 33% of operating income. So it's a very powerful business model. We are pleased with our financial performance in 2025, and building on this strong financial foundation, I want to talk about the opportunities in the future and our future long-term target model. And of course, it all started with the opportunities. I think this team has invested during the last decade to position ourselves to be able to capitalize on the very large opportunities Lisa highlighted. The data center opportunity, we expect to go from $200 billion this year to over $1 trillion in 2030. So within this, really, given this very large market opportunities, we do see a significant step up of our growth trajectory. If you look at the last 5 years, we were able to deliver a very impressive 21% top-line revenue growth, which is driven by significant data center expansion at 52%. And our core business, which include client gaming and embedded business, including Xilinx, growing 10%. Looking ahead, as Lisa and the team talk about this, we expect our data center business to expand more than 60%. Then talk about the significant server TAM expansion driven by AI adoption and how we can target the market share gain to more than 50%. And Forrest Vamsi talk about the inflection of our data center AI business, which we expect MI 450 to start to ramp in second half of 2026. And we see a trajectory to tens of billions of dollars of data center AI revenue in 2027. And of course, a trajectory Forrest talked about it to be more than 80% CAGR for our data center AI business. Then coming to our client gaming business and embedded business, they are vital and diversified element of our business model. Jack talked about the client business, the tremendous momentum of ASP increase and the market share gain will continue to drive that share gain to more than 40% of the market. And Salil just talked about the significant embedded business design wins and the market recovery, which will outpace the market growth going forward. So when you combine that together, we expect the overall company to expand more than 35% in top-line revenue growth. And if you look at our long-term financial model, we expect top-line revenue to grow more than 35% during the next 3 to 5 years. We expect our gross margin to be in the range of 55 to 58%. And we expect our operating margin to be more than 35%, the tax rate of 13 to 15%, and the free cash flow margin more than 25%. So as a management team, we're very excited about building on this business momentum we have today and execute toward this long-term financial model. Of course, I'm going to double-click on 2 areas I know all of you are going to ask me about: gross margin and operating leverage. First, on gross margin. We do have multiple drivers that we can continue to expand our gross margin. First is scale. It's classic operating leverage. You guys all know our team does a great job to leverage scale volume to driving gross margin expansion. Second, optimization, which is about yield, test time improvement, design for cost. Those are really important for AMD because we actually have a broad product portfolio and we target all different end market and with very high volume. Some of our product lasts for a long time. So when you make the yield and test time improvement, you actually can make significant impact on gross margin over time. Our operation team has done an excellent job there. I'm very confident they will continue to do so. Third is mix, which remains to be the primary driver of our gross margin. I'm really excited about several tailwinds we have. First, on the client side, Jack talked about how the ASP increasing, moving up the stack has helped us on the revenue share. Frankly, it also helped us with our gross margin expansion. More importantly, we do think we have an upside to continue to expand the client gross margin because right now it's still very much lower than corporate average, but we do think the opportunity to expand gross margin going forward is going to help the company generate a tremendous bottom line and cash flow. Secondly, on the mix side, then talk about the server business, continue the momentum and the market share gain. More importantly, we are at the inflection point to gain more share on the enterprise market side. Every point of enterprise market share gain is significantly accretive to our overall gross margin. And Salil talked about the opportunity to outpace the market growth with really high margin business, especially AMD Xilinx's FPGA business is very strong in aerospace, defense, industrial, testing, emulation. We see significant gross margin expansion and growth from those business. So with those really tailwind, I feel really good about continued gross margin expansion. And then let's talk about data center AI business. First, Forrest mentioned earlier, we are not selling the rack level system solutions. Our business model is not going to change. We're selling GPUs, CPUs, sometimes DPUs. So it continues to be the same gross margin structure like we have today. And today, it is true, our gross margin is slightly below corporate average because our objective right now is really to scale our business to make sure our customers get better TCO and also getting more market share. So in a fast-growing market, maximizing gross margin dollars is our #1 priority. But over time, when we continue to add more capabilities each generation, we also can optimize our designs for workload. With the scale, we can optimize manufacturing business and operations. We do see our gross margin to continue to steadily improve over time. So when you put it all together, there are puts and takes. That's why we're guiding a range of gross margin from 55% to 58%. The mix dynamics certainly determine that, including the pace and the rate of our data center AI business ramp. But overall, we feel really good about the trajectory to continue to expand gross margin going forward. Then operating leverage. 2025 is an important year for us to invest. Given the large opportunities we have, the team is leaning in to accelerate not only the hardware roadmap, but system software investment. We also did acquisition of a ZT System and several software acquisitions to add our capabilities to address these large market opportunities. But we are very committed to drive revenue growth to be faster than operating expense growth. On R&D side, we'll continue to set it as a priority, but we're driving AI adoption across all our engineering team to improve productivity of the company. On SG&A side, we'll continue to tightly manage operating expense and also drive automation and AI adoption to drive operating leverage to drop to the bottom line. So when you look at our long-term model, combine the 35% top-line revenue growth with the more than 35% operating margin, it's a very powerful combination, and we do expect to drive our earnings per share to be more than $20 in the forecasted period. It's very exciting, and the whole team want to execute on this model to deliver just like the track record that this team has showed you in the past. Now let me switch to capital structure and capital allocation. Our business model generates very strong free cash flow. If you look at 2025, we expect to more than double our free cash flow versus last year. And we have a pristine balance sheet and very strong investment grade. We do view that as a strategic asset. It's a tool in our toolbox we can use to continue to drive a company's growth trajectory. And we are also committed to return cash to shareholders. Since 2021, we have returned $8.6 billion cash to our shareholders through buyback. So our capital allocation principle continues to be the same. First and foremost is investing, especially when you look at the large market opportunities ahead of us. Organic investment and acquisitions to really enhance our capability to continue to deliver returns to our shareholders. And from a shareholder return perspective, we'll continue to commit to do the buyback to return cash to shareholders. Of course, offset the employee stock dilution first, but we'll do additional buyback when opportunities rise. Overall, we will continue to maintain our strong balance sheet and financial flexibility to continue to invest for the future. So in summary, it's a very exciting time to be part of AMD. We are targeting over $1 trillion market opportunity, and we are driving top-line revenue growth more than 35% and operating margin more than 35%. And our disciplined capital allocation approach will allow us to continue to compound earnings per share, to drive earnings per share to be more than $20 during our forecast period. With that, I'll invite Lisa to come back to give closing remarks.
Okay, well, that was a lot of information for one afternoon, so I promise to keep the closing remarks very, very short. But maybe I'll just give you a little bit of perspective. I mean, I've been CEO of AMD for a little over 11 years. I'm super proud of the team that we have. And I think the key message is we've always been really clear about what our priorities are. It's about delivering great products and great technologies to the market. It's about having very, very deep and strategic customer relationships. And I can say for sure that there has never been a more exciting time to be at AMD. If you think about the incredible market opportunity that's out there, if you think about the product portfolio that we have, I think we know how to execute, and we know how to execute at scale, frankly. It's quite different running a $4 billion company to running a $34 billion company. And the only way you do that is with a fantastic team that really knows how to optimize every aspect of the business. And we also have, I think, a history of very strategic and deep partnerships. I think what you're finding right now in the market is favoring those who can partner, those who can bring people together. Because at the end of the day, I'm a firm believer in there is no one company that has every solution that's needed in the market. Frankly, what we love is building those partnerships that are like 1 + 1 is much greater than 3. In the sense that we bring to our customers something that they could never get on their own, and they're bringing us insight that we would not get on our own, and that's how we're putting this all together. And the other part is to ensure that for all of you, as our shareholders and our supporters, we're also committed to having a very exciting market return for you. And I think Jean said it best, so we'll follow up with her numbers. We've shown you a lot of numbers today, but perhaps the 3 most important ones are best-in-class growth with greater than 35% revenue CAGR, greater than 35% operating margin, and greater than $20 EPS. So with that, thank you again for spending the last few hours with us. We are super happy to be able to spend some time to talk about the long-term view from AMD. And I think we're going to transition into Q&A at this point. Thank you.
Thank you, everybody. Give us a few minutes to do a little scenery change. While we're waiting for the guys to set up the chairs and for the team to come up, just a couple of housekeeping items and sort of rules of the road on Q&A. No 11-part questions, please. So we're gonna Liz and Prab from our IR team are gonna be running around with roaming mics, and we'll kind of call on you guys to ask questions. We'd really appreciate it if you kept it to 1 question per caller. And then while the team is sitting down, after we get done with Q&A, there's gonna be a cocktail reception over here, I guess to my left, to your right, all the way around the corner there. There's a bunch of different demos of technologies from across AMD's businesses, including a very interactive, fun thing about the Helios rack that's a big touchscreen display thing that's actually really cool. So as we wrap up, there's some After a day of talks, everybody needs a cocktail. Plus, there's some great demos in the back. So thank you very much for all of your attention today on us presenting the business. I've been at the company less than a year, and I've worked with all of these folks for a very long time in my external role, and it's just incredible what the team's executing against. So if you guys don't mind sticking your hands up for questions, maybe we'll start from there. Since Tim was looking over my shoulder the entire time during the presentation and peer pressuring me, Tim, go ahead.
I just had a quick two-part question. So, sorry. So, Lisa, first on customer concentration. So, we see the big deal with OpenAI, and there's some overlap with Oracle as well. So, how do you think about in this time frame? How do you think about customer concentration in the data center GPU business? And then quickly on component cost increases, Gene, how did you factor that into your model? It seems like you don't buy a lot of these components, but they could really hurt the PC and the server TAM. So I'm just curious your thoughts there. Thanks.
Sure, Tim. Thanks for the question. And look, the way I would say it is the following. We are super excited with OpenAI and the strategic partnership we announced. I think it sets a foundation, given its size and scale, 6 gigawatts over 4 or 5 years. I think that is a key foundation. But the way you should think about it is, our goal is to have really a very broad set of customers. And there are, multiple customers that we are engaged with right now at similar scale, multi-gigawatt scale, multi-generation, with the notion of, MI450 is an extremely competitive solution. I think I don't want to under-describe sort of the big leap there. We've done great job with the MI300, 325, 350 family, but MI450 opens up a lot more TAM for us. And I think with the work that we've done on both the hardware and the software platform, we've been deeply engaged with a number of customers, all throughout this period. I would say even since the OpenAI announcement, it's really opened up some additional opportunities with the notion of, look, and I said it, there's an insatiable demand for AI compute, and MI450 is an excellent solution, and I think that's the really anchor point for the type of growth that we're talking about. So yes, OpenAI is an important foundation, but we will have multiple hyperscalers in the same time frame, multiple customers at gigawatt scale, and multiple customers that are looking at multi-generational roadmaps with us. I think as we go forward, we even get even more tailored to some of these workloads. So it's like every time we engage at this type of scale, we learn and we get even more tailored to the solutions. I think you saw that in Dan's roadmap when he talked about what we did in Epic. I think we're seeing a very similar trajectory with just the depth of the partnerships with the broad customer set.
So on the component cost question, it's a great question. As Lisa mentioned, it's very complex. But Forrest and our operation team have been working very hard to ensure not only we have the supplies component, that we know exactly the cost of the component. So we have been very disciplined about that to ensure we can support our customers.
All right, Vivek here in the front. Thank you.
Great, thank you. Vivek Arya from Bank of America Securities. Thank you so much for an informative Analyst Day. So Lisa, I'm trying to understand how you came up with the 80% growth rate forecast for AI. Is it bottoms up? Is it top down? Because if I look at what it mathematically means, it's about 120-ish billion, right, plus minus by 2030. So if I take that $1 trillion TAM, it suggests that your share aspirations are somewhere in the mid-teens. But how much of that number is ASICs? How much of that is China? So what I'm really trying to get to is what are really your market share aspirations? And this 80% growth rate, is this built up from bottoms up, visibility, discussions with customers, or is it based on TAM and then a market share aspiration on that?
Yeah, absolutely, Vivek. So many aspects to that question. Let me try to get through it. Look, when we look at TAM as well as revenue projections, I think we do it first of all in the near term. It's bottoms up. So bottoms up to look at what exactly are our engagements with customers, especially when we're talking about things like 2026 and 2027. Frankly, the lead times for wafers, for memory, for components is so long that we need to have that very detailed conversation many quarters out with our customers. And then as we get into the medium term, it's more strategic conversations with customers. We don't do much from a true tops-down perspective because, again, that's sort of a little bit math. But the way to think about, sort of what are our thoughts on the TAM? The TAM, we believe, in this strategic time frame, that TAM includes, GPUs, it includes ASICs and accelerators, and our view of that has not really changed. I think we've been consistent. I think there's a place for ASICs in the accelerator TAM. ASICs tend to be good if your models if your algorithms are a bit more stable and if you know exactly what's going to happen next. GPUs, we're innovating at such a fast pace, at the annual pace, with all the new data formats, with all of the new algorithmic things that are coming out in the models. I mean, GPUs, we believe, will still be the predominant percentage of the TAM. So, ASICs maybe 20 to 25% of the TAM, and the rest of that being GPUs. And then in terms of, how do we think about China? I think China is a complex and dynamic situation, certainly as it relates to us, being able to service China. As we said in our latest earnings call, we've taken China out of our revenue forecasts because it's too hard to call right now. We'd still like to sell to China, no question. But relative to the TAM, it's also a small piece of our TAM for, again, that's the best visibility that we have, at this point in time. And we'll continue to update it, as we go forward. Hopefully I covered your questions.
As someone who spent the majority of his teenage years sitting in the back of the class, Joe, I see you way back there, so don't want the last row to get left out.
We did not know where Matt was going with that, so we didn't know, you didn't know, but.
Yeah, Joe Moore, Morgan Stanley, thank you. I guess on the same lines, how do you think about market share 5 years out? I mean, either you're delivering better ROI than NVIDIA is, or you're not. Like, what's the case for low teens type of share versus much larger share or much smaller share, depending on kind of how you deliver technology-wise? Yeah,
Joe, let me comment on that, and that was part of Vivek's question. Look, I think the key thing for us and for the market is no one enters a market to be a very small share, right? So we enter a market thinking that we can be a meaningful portion of the market, that we're delivering value. That value is coming in sort of technology capability, like we are doing things in different ways. We're offering, products that have, really leadership in certain capabilities. And we're also offering overall total cost of ownership. All of those things are important. So, certainly from a, market share aspiration, we mean to be, a meaningful portion of the market, meaningful double-digit percentage of the market. Now, the market changes, all kinds of things change, but, our view is that there is no other silicon TAM that is as exciting as the data center TAM, and especially the data center AI TAM. And so we have gone all in terms of strategic investments in this area. And I think we have a very, very strong roadmap. I mean, you heard, sort of the very early pieces from, Forrest and Vamsi about what we're doing. MI450 was a significant step up. MI500 series is another very significant step up. And, with that, we see opportunity to really differentiate in this market, especially as there's really just a diverse set of workloads. Like what you need, for the highest end training may not be the same thing that you need for, your best throughput in inference. And actually, I can say for sure, it's probably not the same. And as a result, there are ways that you can tailor products such that you will get best total cost of ownership. And when you're investing CapEx at this scale, I mean, it is absolutely worth it for the largest hyperscalers to find the most optimized solutions. And that is, I think, what we see is the conversation is much more workload specific today than do you have a GPU that works?
Sticking with the back row theme, Stacy, go ahead.
Thanks. Stacy Rasgon at Bernstein. So you've talked about, tens of billions of dollars of AI revenue in 27. You do, I don't know, $6.5 billion or so this year. If I just took that 80%, that would put you at, I guess, around 20 or 21 billion in 27, which I guess is tens. Now, maybe it's possible that the growth rate should be faster in the early years than in the later years, just given the base is smaller. I think the street's modeling, I don't know, 29 or 30 billion in 27. Like, how do you feel about your, I guess, that medium-term trajectory relative to where those kind of current expectations are?
Yeah, I think, Stacy, the way I would say it is, since we're giving a 3 to 5 year TAM, and the outer years have a little bit less visibility than the near-term years, we would expect the near-term years to grow faster than 80%, so greater than 80%. And I think we are, comfortable with tens of billions of dollars being in the zip code of, let's call it where some of the thoughts are, overall. Maybe do you want to add to that?
I think you covered it. I think when we look at the current consensus for 2025, it's roughly in line, and we do expect, like Lisa said, to grow faster.
Josh over here on the right, my right.
Thank you for taking my question, and thanks for hosting such an informative day. I think, Lisa, in your prepared remarks today and on the earnings call last week, you called out multiple gigawatt scale projects that are in development. What hurdles need to be cleared to convert those, both on your side and the customer side, and any context or scope you're able to provide on what those look like compared to the OpenAI engagement you were able to give us a lot of details on publicly? Thank you.
Yeah, so Josh, thanks for the question. I think the best way to say it is, we have very deep relationships with the hyperscalers and all of the hyperscalers and many of the top AI native companies. You can imagine that everyone is super interested in MI450, and we expect that MI450 will be deployed at very significant scale. In terms of multiple gigawatt customers, my comment is really around just the scale of forecasts that we're getting from customers on their near-term needs. So there is a desire for a significant amount of compute. We are working with the supply chain today to make sure that we have the broad ability to support all of the compute that's required, and just to make sure that we have that out there. I think we have built a supply chain for the type of growth rates that we're talking about, and I think the customer momentum is very strong. So much of the work right now is continuing to work with Vamsi on some of the software aspects of it, but it's really in execution mode for MI450. As we get those fully ramped up and validated, we would expect to convert a number of those opportunities.
All right, I'm going to shift gears and go to the front row. Oh, Liz, I can do it. Don't worry. Here you go, Aaron.
Yeah, thank you very much. Aaron Rakers with Wells Fargo. I want to shift gears a little bit. The embedded presentation, there were several references to semi-custom opportunities, particularly around the data center side. So I'm curious of what exactly is that? Are you going to participate in some, if I call it XPUs or XPU attach opportunities? When do you see those maybe materializing? And Forrest, real quickly, I'm curious on Silicon Photonics, NOSemi, I think was an acquisition you made. Where does that stand in kind of the strategy from a rack scale perspective as well? Thank you.
Yeah, sure, Aaron. Maybe I'll start, and then I'll let Forrest talk about optics. Look, semi-custom has been in our strategic sort of tool chest for the last number of years. I really believe in this sort of business model. It's actually not a product, it's actually a capability to take our IP and really tailor it for specific applications. I think Salil has done a particularly good job at taking all of the semi-custom components and our technology IP to some of his top embedded customers, and they've seen a lot of value in that. And so you saw in their aerospace and defense customers, automotive, a number of communications sockets as well, where there isn't something that's very easy to pick off the shelf, but we have all the pieces for them to put it together. To your specific conversation about data center, we have won several data center semi-custom opportunities. They tend to be more, not the compute unit itself, but some of the attach around the entire system, including some networking components and some other specific components. I think if you were to fast forward and talk about how we could imagine semi-custom evolving, I think you can imagine semi-custom as built off of our GPU compute capability. So the idea that the beauty of chiplets is you really can customize pretty easily, right? You could take our entire foundation and say, hey, let me take this compute die off, sort of the AMD standard product, and put on a customer specific standard product. And I don't know what you call that. Do you call that a GPU, or do you call that an XPU, or do you call that a GPU plus? But at the end of the day, what we're trying to do is provide workload-specific optimization for the highest volume sockets. As I said to Vivek's question, I still believe that standard product GPU will be the largest driver of growth, just given the rate and pace of innovation that's happening there. But there may be opportunities for us to do customized GPUs as well if there are specific workloads or use cases. I think it just broadens our overall capability in the data center space and really across the computing space. Maybe for us on the optics.
Yeah, and Aaron, I think on the optics side, for the last 20 years, I'd say that silicon photonics and optical interconnect within the rack has been, a technology that's always 3 to 5 years out, and it's been that way for the last 20 years. And the ingenuity of the engineers in getting copper-based solutions to continue to scale has been incredible, and better than expected. And so that's pushed that horizon of the age of optics out continuously. I think as Mark mentioned earlier, we're approaching the point though where it's pretty clear that just the age of optics, is almost upon us, and that we see that time horizon that's indefinitely been out there is collapsed. And so in the we believe in the 27, 28, 29 time frame, you're going to see a transition. First in the large scale rack level systems for scale up fabrics, and then over time other places as well, you're going to see a transition to optics, and it just from a I/O density point of view, from a bandwidth point of view, from a power point of view, it just makes all the sense in the world. So we're certainly getting fit to fight. You mentioned InnoSemi. That was a small acquisition to augment our already existing optics team. But as Mark said, we feel in 27 and beyond, it's an era where optics and SerDes will continue to coexist for a short period of time, but it's all going optics long term. I don't know if you wanted to add anything to that, Mark.
No, well said.
All right, I don't know what it is about cell side, either in the front row or the back row, but Chris Rowland in the back there.
Thank you so much. Chris Rowland, Susquehanna. Mine is for Gene. Gene, if I'm doing the numbers right, it seems like maybe OpEx growth is, call it mid-20s versus revenue growth at 35. I guess, first of all, should we front-end load that? Could it even be higher than 25? And then secondly, the street's dialed in for high teens for next year, mid to high teens. Does that mean like the direction of travel is higher, and should we adjust our models?
Yeah, Chris, thanks for the question. The way to think about it is 2025, it's really a year we're leaning in, investing significantly more. So if you look at the OpEx increase this year, it's actually pretty high. But going into next year and going forward, we do believe we can drive revenue growth to be higher than OpEx growth. So year over year, I would not suggest you to front load all. It's literally from modeling perspective, what's the best way to model it? You can just model it that way. So I don't have a clear path, right? We're doing our 2016 annual operating plan right now. So it is, as I said, a rigorous planning process to figure out where we're going to invest. But one thing I can tell you is revenue growth next year will be higher than OpEx growth.
Right. I think I can't see Brett, but I know he's behind that very large pole, so we'll go back there. Thank you.
Yeah, thanks. I'm hiding here in the background. It's Brett Simpson at Arete, and thanks again for hosting an informative day. Lisa, my question is about supply in the industry, and you put out a large CAGR for data center, and the TAM in 2030, it translates to a huge amount of fabs that need to be built for the industry. So my question is, I guess, DRAM looks like it's going to get really tight into next year. Foundry at leading edge is extremely tight as well. So can you maybe talk about what AMD is doing with their key suppliers in terms of getting aligned with how you see the growth trajectory in AI? Thank you.
Yeah, thanks for the question, Brett. So look, we have been actively planning the supply chain all along. So, certainly for the last few years and, going into next year and the following years. I think the fact of the matter is, I think we have a lot of experience in, sort of being first on some of these things. We're very early in the advanced nodes, so planning is very important. We're very early on high bandwidth memory. So planning is, super important on that. And the best thing I can say is, for sure, the supply environment is getting tighter. But I can say that, we feel very confident that we have the overall supply chain capability to support the growth model that we're talking about. And the key about the industry in general is we've generally been able to, really get supply to ramp when it's clear where the demand is. And as everyone's putting out their markers right now in terms of what they think the overall demand is, we're working very closely with our top suppliers to actually triangulate all of that and ensure that we have, really our fair share of the growth that's needed to support all of this.
Here you go, fine, sir.
All right, thanks. Ben Reitz is from Melius. Thanks for having us, and appreciate it. I wanted to readdress the first question with regard to OpenAI and say something that's on everybody's mind. There's obviously this worry about OpenAI that's just with the customer concentration, the CapEx concentration in the industry. People are particularly worried about it now. I'm sure this isn't news to you. You just put out these really great forecasts that are awesome, and congrats. Did anything happen that makes you just more confident about it, maybe more line of sight on the 6 gigawatts? Anything you can say to comfort a crew that just on the customer concentration question that gives you more conviction in these great forecasts, considering they can be 20 billion plus in revenue in a given year?
Yeah.
Thanks so much.
So I think the best way to think about it, Ben, is the following. First of all, I will say, OpenAI is definitely one of the most aggressive when it comes to their compute forecasts. So that is definitely true. I think the way we've structured our engagement is it's a very disciplined engagement. I mean, as much as we like the headline numbers of 6 gigawatts, over the next 4 or 5 years, it's a very disciplined engagement on what do you need each year and where are you going to get it from. And the expectation is that, we've already said the first gigawatt will start in the second half of 26 and will go into 27. It is a very disciplined way of saying, hey, and we expect it to be installed in these data centers at this point in time. This is when you have to have your supply ready. And that's the only way that we make these types of things happen. This was, really what was so important because it is such an impactful deal is to ensure that we put all of those measures in place in dealing with OpenAI as a customer. That being the case, I will say that we have a broad base of customers that we serve in the data center, and include the comment or the question earlier about customer concentration in the data center AI business. We expect to have multiple, similar size customers in the strategic timeframe, in the MI450 timeframe. That is how much interest there is in MI450. So that means that we're dimensioning the supply chain to supply, multiple, gigawatt scale customers, and we're working with our partners to do that. So I think the best way to say it is, we are quite disciplined in how we plan these things. I mean, it's significant, scale and significant volume, but we're also quite, comfortable that we know how to do it.
All right, we're going to do a little ping-ponging here. Antoine, I think you're way over on this side, and then we're going to go to Will, who's way over on that side, just for fun.
Actually, maybe if I want to ask one on the edge AI opportunity. So you've been mentioned. I mean, there's been a lot of chatter, around a lot of compute from content delivery networks, edge telco. I'm just wondering what use cases AMD is seeing at the edge.
Maybe Jack and Salil, do you want to come on up and say a couple things?
We're already seeing use cases in the 500 billion parameter model. If you think about the latency from the cloud to the endpoint, we're seeing opportunities in hospitals, education, factories that just want the workloads to be much lower, closer to the endpoint, right? And we just launched our first Radeon AI Pro card just actually a few weeks ago, and demand is actually looking pretty good, right? So think about it as we have a broad range of capability across tens of billions to hundreds of billions of parameter models, and we're seeing workloads as very diversified, and we want to cover every possible workload out there.
Yeah, so we do distinguish between edge AI and physical AI. So I'll talk a little bit about physical AI. And physical AI is where AI is being used in the real world, basically things like autonomous driving, right? And it's drones, robotics, and things like that. But it's really cutting across all industries, I would say, right? Almost every application, every algorithm is being rethought these days. And people are thinking about how do we apply AI instead of the traditional algorithms, right? Things, you probably in the past you heard of OpenCV and vision algorithms. None of them exist anymore, right? We have all the AI algorithms, right? So in some ways, right, every device, every application in the physical world will have some AI infused in them, which is why the TAM is super big in the silicon TAM for physical AI. Okay?
All right, Will.
Thanks for taking my question. It's Will Stein from Truist Securities. Lisa, I thank you for hosting such an informative day with these very nice aspirational TAMs and margins and all the earnings growth. It's wonderful. And I appreciate your prior comments about the diligence in building up this forecast. But there's two constraints that people ask me about a lot that seem a little bit further away from AMD's control than what we typically see. One is your customer's ability to fund all of this, and the other is their ability to source power. How much time are you spending on those things? And I think we'd really appreciate some clarification as to why you believe that this is going to be able to be funded and powered, and should we expect other sort of off-the-run financing deals like we saw with OpenAI? Thank you.
So a couple different questions there. So to answer your question on how much time do we spend on, let's call it the things beyond delivering, Helios and the GPUs and things like that, we spend a lot of time on those things, right? We have to. I mean, that is part of how we get comfort and confidence in size of market and what happens. So certainly on power, we're spending quite a bit of time looking at the power roadmap. Not just for our customers, but just around the world. Where do we see sources of power? We're talking a lot about the U.S., but you should think that there are significant ramps in power outside of the U.S., especially when you look at places like the Middle East, Southeast Asia, a bunch of other places. So we're looking at power roadmaps there. We are working actively with each of our large customers on their power roadmap to ensure that we know when their data centers are ready. So that's how we're matching up the forecasts. And then the second point, as it relates to how do we think about financing, certainly financing is a key piece of it. Maybe if we just put OpenAI aside for 1 minute, because I think that might be a bit of a topical conversation. All of the other large hyperscalers who are talking about raising their forecasts are extremely well funded. I mean, their balance sheets are really strong. And the fact that they are choosing to invest more in AI should be a good indicator to the audience that they see value in it. I can tell you the same customers that I might have talked to 12 months ago or 18 months ago maybe didn't say that they weren't forecasting that their CapEx would just keep going up. What they've seen is they've seen real value in their business and in their sort of overall strategy to do that. So I think we should feel confident that the hyperscalers can afford to invest the type of CapEx that we're talking about, and it's because they expect to see the return on the other end. And now coming back to OpenAI and addressing that, there's no question that OpenAI is leading the market in terms of forecasting what they want in terms of compute. I think, again, not to speak for them, but if you take a look at some of their numbers and the growth of their user base, the growth of their ARR, and just the amount of users that still don't have as much compute as you want, I wouldn't bet against that. I really wouldn't. What we must do as sort of good stewards of the company are ensure that that everything is cause and effect. And I think that's why when you look at the structure of our deal with OpenAI, it's a very much aligned incentive structure in the sense as they see visibility for obviously funding and installing all of that GPU capability or AI capability, we also plan together with them. And the reason that we are so forward-leaning on this is it is great for us in terms of just the amount of learning that we get from engaging at gigawatt scale with a customer that's on the bleeding edge of foundational models. I mean, that is, I would say, Vamsi's team has had a lot of torture, but also a lot of fun in the process. So I think we're doing this in a very structured way. We absolutely think about all of the aspects that you're talking about. And when we look at all of the above, we say this is a very unique moment in AI. And we shouldn't be short-sighted in thinking about, hey, are you going to see returns in a couple of quarters, or are people going to be interested in financing it? If the AI usage grows as much as we expect, I think there's going to be plenty of financing for all of the return and capabilities that are there.
Blaine.
Hey, thanks, Blaine Curtis at Jefferies. Maybe an AI adjacent question. I wanted to ask on general purpose servers. You showed the market accelerating. I didn't know how literally to take the 60% overall data center and then 80% AI. It would get you a pretty substantial double-digit server number. So maybe how are you thinking about the market and then your growth on top of it?
Yeah, you want to take that, Dan? You can take it.
Look, hey, Blaine, thanks for the question. So on server, look, I showed the TAM for AI. The general purpose TAM is also double digit, right? So we believe that there's a lot of growth potential there. And with our roadmap, we believe that we could definitely far outgrow the market as we have been and continue to gain share. I'm not sure if that got to your question.
Maybe let me add something to that, Blaine. If what you're asking is what are we thinking about server TAM? And yeah, so server TAM, I think Dan showed something like high teens TAM growth rate. Yeah. The way to think about that is, though, again, back to the question of how do we get to those numbers. In the near term, we have very clear forecasts from our customers for 2026, 2027. The uplift in sort of cloud demand has actually surprised us. And we saw the first aspects of it a couple of quarters ago. It was maybe one customer who we thought, well, maybe they're building ahead or they're refreshing. And now we've seen it at multiple hyperscalers. And when we ask underneath it what's happening, it is as Dan described. There are multiple vectors. As you have more AI inferencing that's being done, you need more general purpose compute. As you have agents really start kicking in, it's like having 1,000 more people. Like they have to be computing on something, and they need general purpose compute to compute there. This feels like a real durable trend, and I think that's really nice because there was this debate. I mean, frankly, for the last couple of years, we showed the TAM was relatively flat, right? There wasn't a lot going on. There was a little bit of, I think people were holding off on some of their refreshes as they were trying to figure out how much to invest in AI. And now they've realized that, yes, I have to invest in AI, but yes, I have to invest in general purpose compute as well. And it plays really well into our roadmap, just given the strength of our overall roadmap.
Liz, maybe you could come to Gary, and then Lou will be over here.
Thanks for taking the question. Gary Mobley at Loop Capital. I had a question about ARM-based compute, not as a competitive threat, but as an opportunity. Now, I understand that you use the N-series cores in Pensando, and whatever you do in Xilinx as well. But what about licensing or creating V-series ARM-based processors for head-end compute, or even leaking into the custom compute opportunity?
I'm going to talk a little bit about where we use ARM, and I can add.
Yeah, so we certainly, so ARM is a partner for us in a number of different products. We use, as you mentioned, we use some N cores in the Pensando technology. We use some of the semi-custom products as well, and we expect that to continue. I mean, they've got a strong roadmap, and there's some applications for which that's a good fit. Certainly beyond that, if there's semi-custom opportunities where customers particularly want ARM as a compute engine, we are more than happy to do so, and we've invested in having our foundational infrastructure be able to support either x86 or ARM compute elements. So the Infinity Fabric that Mark talks about all the time, that plumbing is set up to give us diversity. So it really will depend on customer choice. But I would be remiss if I didn't also say that for Dan's roadmap, we think that we are certainly competing for TCO and performance advantage, not just with Intel, but also with ARM, and we really like his roadmap. We think that it offers outstanding performance, outstanding TCO value at multiple different points. It's one of the great things about having both the performance and frequency optimized cores as well as the cost and area optimized cores coming from the same technology tree. It gives us very broad coverage of pretty much every space that's pertinent in the data center. So I really like Dan's roadmap against all comers.
Okay, thank you. Lou Misosha, Daiwa Capital Markets America. So the comments before about Edge AI seems very interesting with potential great growth. I realize writing applications on the enterprise or the consumer side takes a lot of time, but when do you think we'll actually see an inflection point there? And also, given if I saw the charts correctly, you talked about growth and share gain, but you didn't give a TAM. So anything that you could fill in there would be very helpful.
Jack, you want to take that?
First, on the client TAM, we're projecting low to mid-single digit in the next 3 to 5 years. Then on Edge AI, beauty of it is we have the same ROCm software stack that goes from Instinct to our Edge portfolio. So we make it very seamless for our developers. And we're just getting started. So we have our first Rihanna AI Pro Code that we just launched a few weeks ago. And we're going to build out this roadmap to be AI first versus gaming first. And you'll see future products that we haven't announced yet in upcoming updates.
CJ, I see you in the back, and you were kind enough to wear a tie. Well done, you.
Coming behind you.
I figure if I'm sitting in the back row, I should probably dress nice. But thank you for today. Appreciate it. CJ Muse with Cantor Fitzgerald. So clarification and then a question. Clarification on the $1 trillion TAM and your target revenues. Are you including HBM in there? And would be curious how you're thinking about HBM within your gross margins. And then to my question, curious around your partnership with OpenAI and their Triton software stack where, try to kind of make heterogeneous hardware environment. Would love to know how that is informing your business with them and how perhaps that's enabling you with other customers. Thanks so much.
Sure, CJ. So clarification on the $1 trillion TAM. So that is a silicon TAM. So that includes GPUs, that includes the HBMs that go with the GPUs, that includes CPUs, and that includes actually the networking part of the market that we service. So let's call it scale-up networking. It doesn't include scale-out and switches. And the way we think about HBM is on the stuff where we're doing the primary design, we should get a healthy margin. I mean, that's where all of our investments are going. For the things where we're attaching, I think we are adding value in the overall, let's call it package, but we're not expecting the same margin on HBM. And I think that's fair because if you think about just where the value is coming from. We want to ensure that in the end, we have a good, overall TCO to our customer set. So that's the way I would state how we're thinking about it. And then in terms of, OpenAI and the heterogeneous environment, maybe Vamsi, I'll let you talk a little bit about the software environment.
Yep. So maybe first I would say that the work that we have done with Triton is very aligned with our overall strategy to leverage the rising abstractions, right? So Triton is actually a higher level programming abstraction, so it's more productive and easier to compile to hardware. So that's why we collaborated with them. It's going well, the Triton enablement. And what it does is, when a new workload comes along, it actually takes down the amount of time to get onto hardware. So if you have, let's say, a model that's stitched with, let's say, 100 kernels, maybe there's a few kernels that will remain to be written, with a little bit more sort of lower level programming, but a majority of them can actually be compiled with Triton, and it gets us to market faster. So that's the advantage. And also the work is not specific to OpenAI. Triton actually is used quite heavily in the industry. When a lot of the new day zero support comes along, actually it gets enabled because Triton backend support for AMD GPUs is becoming more and more adopted.
All right, our handy dandy little clock here, the yellow light just went on. So I think we have time for maybe 2 more questions. Chris, since you're right here in front of me, I will walk over here.
Since I'm in the front row. Chris Casso from Wolfe Research. Gene, a question for you with regard to the gross margins. And one of the things you said is that in the near term, your priority was to maximize gross profit dollars. How do I reconcile that with the longer term guidance, 55 to 58%? What's the time frame for that 55 to 58? And should we assume, therefore, that the gross margins are diluted somewhat in the early stages of the MI450 ramp?
Yeah, the first thing I would say is if you look at our gross margin, we have been expanding our gross margin in 2025 each quarter. We are ramping MI350 actually steeply in second half of 2025. So overall, from our gross margin profile perspective, we absolutely want to make sure we continue to improve gross margin with all the tailwinds I talk about it. On the mix perspective, as you can imagine, it will really depend on the pace and the ramp of the data center AI business, right? So we said that we're going to start to ramp in second half of 2026, then into 2027, it's going to ramp significantly. Our other business gross margin will continue to go up. That makes a change in that range. Absolutely, if the volume is really high, it could be closer to the 55 range. And relatively speaking, if the mix is dynamic differently, we could be on the other high end of the gross margin. But that is in the forecast period between 3 to 5 years.
In the nearer term, though, is there an early dilution?
The way to think about near term is we are ramping MI350, right? And we'll continue to ramp in the first half of next year. So our gross margin should be quite consistent with what you are seeing right now. We guided the Q4 at the 54.5%. I think the second half, when we start to ramp MI450, that is when it's really going to depend on the volume, right? The pace of the ramp and the volume. Right now, actually, I don't know yet.
All right, so Mr. Lapassis, no pressure. You're the last question before we go to cocktails.
Great. Thank you for the excellent presentations. Very informative. So Lisa, I was actually at the Analyst Day where you guys made the observation that you rounded to 0% share in server CPUs and then made the case that you were going to take share. And I think you upsided everybody's expectations, certainly mine. It seems like there's a lot of similarities in how you prosecuted the server CPU market and how you're going after the GPU market in AI. And I was hoping that you could just lay out that playbook, the important elements of the playbook that you use for CPUs and how you're laying that out right now for the GPU. And then on the other side, the competitive environment, you have a different competitor, and I'm hoping that you could just help us understand what's different on the competitive front from a challenges standpoint. Thank you.
Sure. Well, I'll start, and then I'll let Forrest or Mark or Vamsi add if they have things to add. So look, on the CPU side, I think we always started with the notion that this is about technology, and it is when you have sort of disruptions in technology, you can actually make a really big difference if you make the right technology bets. And I think what you saw a little bit in what each of Mark, Dan, and Forrest presented today is it was actually very, very systematic. I mean, I think when we started with our plan, we said, look, it's going to take us 3 generations to be competitive. However, we know exactly which step we're going to lay out as we went from Naples to Rome to Milan. Post that, it became, we were at scale now. And so when you're at scale, you can actually fan out and address more of the total addressable market. And that's when we went to, multiple cores and multiple, segment optimization. And now I think we're in a different place. And the different place is when you're now the incumbent. So you have to imagine, like, we don't take any share for granted. Okay, so every generation, we have to prove that we are better, and better by a lot. But when you're in the incumbent position, you just have such a different seat at the table, and that's where we are today in server CPUs, especially in the cloud. I think we're planning long-term roadmaps, multiple generations, and frankly, I can't say that we get it right all the time, but our customers are very willing to tell us where we can adjust and where we should adjust so that we can be, a very significant piece of that business. And so, yeah, we're fortunate that at the same time that the market is inflecting, we have, such a strong product portfolio. And if you translate that into the GPU side, it is similar and different in cases. From the standpoint where it's similar, it is foundational is all about the technology. We know that. And we've also had a very deliberate path of going from MI 250 to MI 300 to MI 350. We chose not to do rack scale solutions this year because we thought that would be hard, and we wanted to prioritize time to market of our new data formats and new solutions. But we chose to set ourselves up so that MI 450, we had all of the pieces. That's why we did the ZT acquisition. That's why we did the Pensando acquisition. That's why he's been hiring like crazy on the software side. And then as we go to MI 500, there's another set of significant innovations that are coming on board. So I think it is similar from the standpoint that it's very foundational technology. Where it is slightly different is the size of the market and the speed of the market in AI is different than what we saw in the general purpose CPU market. And I actually think that plays in our favor because when you have a market that's moving that fast and when there's so much opportunity to disrupt and innovate, and when one day you're thinking about training systems and the next day you're thinking about fine-tuning and inferencing systems and you need to deploy quickly, it favors differing solutions. So I think we've made tremendous progress. We give all of our competition lots and lots of credit because that's who we are. We earn every socket. But we feel really good about our trajectory, and I'll let you guys add. Yeah. You can see we're passionate about this topic as a management team. So
we are super passionate. I'll just make a quick comment and connect it back with what you heard Gene in talking about our disciplined capital allocation. We run a very, very disciplined process. When you look at that pyramid I showed of the value of all the building blocks leading down to our product pillars, that capital allocation is scrubbed many times over to understand what value it's providing. So your analogy to the server roadmap, that expanding roadmap was deliberations year after year, several years in advance for the arc of R&D that you need to decide that differentiation by listening to our customers, build it in, deliver it. Same thing the GPU. So we have created a very disciplined process as we make those decisions across every business unit with R&D, closing back with Lisa and Gene, and we're going to continue that going forward.
You know, it's not often that I publicly disagree with Lisa, but let me publicly disagree with her on one point. She said it's all about technology, and I would only quibble with the word all. That is the table stakes that allows you to play at the table. But the other critical element that we learned during the server journey, and that I think is pertinent here as well, is that the other element, because you're talking about a market and applications that are core to our customers, they're very important to our customers. The other element is customer trust. And building that trust where they understand that they can rely on AMD, that they can rely on our technology, that we're going to execute for them. It's extremely important, and we built that in a very deliberate way on the server side, and I think actually we're doing the same thing here as well. Phased approach to building with our lead customers. Trials with MI 250 or 300. Expanding the usage, and things like the validation the implicit validation from large customers embracing MI 450 are very important in reinforcing that lead customers have trust in AMD to provide the core of their AI solutions. And that also is an incredible validation for the rest of the market. So sorry to disagree with you a little bit, Lisa. But just...
That's what a great team is for.
Well said, Forrest. Just a couple of things from me. Thank you to all the executives for coming together here today. You can feel free to give them a round of applause. But I think it's just as important to talk about the people that didn't come up on stage as a whole another part of the executive team that wasn't presenting today. There was a hell of a lot of work done by Liz and her IR team, by Phil and the communications team, by the events team, by everybody at AMD. We're trying really hard to represent the 25,000 engineers and do them proud. And it takes a lot of work to put on an event like this. All my days on the sell side coming to these things, I had no idea how much work it was. I found that out. And I just want all those people to be recognized as well. So Lisa, the whole team, thank you very much. And let's have a cocktail.
There we go. That was a pretty awesome presentation. Looks like the market is actually loving that news afterwards. We are up. Well, I'm up. The market is up. AMD, they're loving the stock here. Up about 3.42% after the market close here. It is 5:13. That was a long call. I've been live the whole time. Make sure if you enjoyed this, you subscribe to the channel. I'm always going live, trying to show you some important stuff or important news that comes up around any given stock that I'm following. So AMD they do this types of earnings once in a while to make sure that they have an analyst day specifically for stuff that they can't just cover all in one earnings call. So I thought this was pretty cool. I hope you enjoyed it. I don't know when the next one's going to be, but it's pretty awesome. Looks like the market did love that. One major thing is that the bond market was closed today, so couldn't really see what was going on in the bond market. But sorry, the bond market wasn't open, so that's how we don't see too much volatility. We didn't see the stock market actually move. Tomorrow we're probably going to see a lot more liquidity in the marketplace. And there's a lot of buzz around this analyst day, and there's a lot of really awesome numbers that AMD has reported here. And if anything, I think in summary, they are showing significant growth and the trajectory that they want to go. They want to acquire companies and grow and be a big portion of the market. And so it's pretty cool to see that they are focused in that area. I mean, I don't know, you either go through the video or maybe they may have a summary of it somewhere of all the presentations, but they reported really good numbers. So AMD just unveiled a long-term model targeting about greater than 20% EPS, which is well above even the most bullish Wall Street estimate. Key assumptions backed into the 20 APS path was 35% revenue CAGR, a 57% gross margin, 35% operating margin, 25% free cash flow margin, and double-edge GPU market share, 60 billion annual GPU revenue. So here are the numbers. If it's not really that clear here, I think I took a picture of what they reported, but Lisa Su today at AMD's Analyst Day. So you can, in summary here, demand for AI compute infrastructure remains extremely high. And one thing, a lot of people argues around like OpenAI and the fact, they're barely making any money, but then they're locking in all these customers for compute, while they don't even have the cash to pay for those products. But Lisa was kind of saying, listen, we built up a very strategic business model with OpenAI where they buy products from us, and when they hit key levels, and so it's not all in one, but rather just like one as based on performance. So when OpenAI buys or gets to a certain stage in their business, they are able to purchase or do business with they're able to do business and buy more of AMD's products. So pretty cool. Customers are not reducing their investments in AI. AMD projects annual revenue growth about 35% CAGR over the next 3 to 5 years. So that is pretty impressive for a company that is $600 billion. What's the market? The market cap? I lied. $389 billion. I mean, maybe it was $600 billion a couple weeks ago when it was all the way at $264 a share, but it looks like it's come down a little bit here. But for a company that is $389 billion, growing at 35 CAGR over 3 to 5 years is pretty massive, and they forecasted data center growth exceeding 80% CAGR as well. So there's if you go through Twitter, I mean, this is a company that a lot of people follow, institution as well as both retail. AMD just seems like in a place of this just J curve, where a lot of the products they're actually innovating is going to be used in the future, such as AI at edge, which is AI being used at the system level rather than AI in the cloud, which makes security, efficiency, cost efficiency, security, and cost efficiency, and then as well as data reaction. I don't know what the word is right now. A lot faster. So having data AI at edge is going to be pretty impressive for them. Looks like there's a whole video somebody has posted. What I'll do is I'll clip up a summary and post it on a shorter video, so we can have a better view of what's going on with the company. But yeah, if you joined the whole time, thanks for joining. I will continue playing the next video, and I think the next video is going to be covering edge AI and Internet of Things in 2025 and 2026, and how that's going to look like. So if you're going to stick around, thank you. Otherwise, make sure you subscribe. Come back. I'm going to be posting the next. I'm going to be covering the next stock that is most likely. I'm going to be talking about Fubo and Kraken, SoFi, BM&U. I think BM&U did recover pretty well today. Actually no, BM&U recovered after market here. BM&R. BM&U, a leveraged version of BM&R. So it did down almost 4% today after hours. Looks like there's some kind of gapped up a little bit, barely any right here. 25 basis points, 10 cents a share. Let's see what's going on in the market. Maybe we'll get something here from Yahoo Finance, and then we'll go from there. Yahoo Finance, it looks like they're talking about renting versus buying, and then we'll just move on from there to Edge AI, and we'll go from there.
Who plan to stay in the rental market for the long term, and a big part of that is the lifestyle reasons that we talked about.
Amanda, great to have you on the show today. Thank you.
Yeah, thanks so much, Josh.
All right, time now for What to Watch Wednesday, November 12th. Going to start off on the earnings front. Got a lot of big names reporting on Wednesday, including Circle, On Holdings, and Cisco. Cisco announcing results for the first quarter after the markets close, and I was expecting the company's earnings to come in a little light this quarter because of the federal government shutdown and higher parts costs. But demand for networking gear is still solid, and AI-related upgrades should keep long-term growth on track. Taking a look at the Federal Reserve, we're going to be getting a big batch of Fed commentary on Wednesday. Investors will be listening closely for any clues about the Fed's path forward with monetary policy as it gears up for its last FOMC meeting of the year in December. And finally, we may be coming to the end of the longest government shutdown in U.S. history, the Senate approving a funding measure on Monday to reopen the government, the bill now being sent to the House for a vote, which could happen as early as Wednesday. Well, we're nearing a big day here at Yahoo Finance, our annual Invest event. It's this Thursday, November 13th, starting at 8 a.m. Eastern from our New York City studios. Got a special full day of live global coverage of the key themes driving the market, AI, crypto, and much more. With the top people in corporate America you'll want to hear from. Questions for our esteemed guests are now open and flown in on the Yahoo Finance community channel right at the top of our homepage. Some of the questions we have already gotten are awesome. Keep them coming. And don't miss Yahoo Finance Invest live all day on Thursday, November 13th. Save the date and tell your friends. That's going to do it for today's Market Domination Overtime. Be sure to come back tomorrow for all of your coverage leading up to and after the closing bell.
Invest back in this huge data center theme. And CoreWeave does have a higher debt profile than some of the other companies out there. Is that something that concerns you? What would concern you about it? What do we need to watch there?
So I think that there's a couple concerns there. One, yes, the debt level. We have to watch not only the actual debt level, but its ability to service it.
Right.
So of course we want to pay attention to some of those other metrics that are out there, EBITDA to interest, for example, and we can kind of help balance that concern depending on what those metrics. There's also what folks are calling, the money shell game, if you will, or the money shuffle between different companies. And, no question we have to watch it. But I think when we step back, Julie, and we think about where we are with AI adoption, and there's a great report out from McKinsey, that's scanning a variety of enterprises. And what it shows is that, yes, a lot of companies, around 88%, have at least one use case for AI, but only about a third of them are really starting to scale. That tells me that we're still not, early days, first, second inning. I think we're more third, fourth inning. And, as I've shared with folks at the Street Pro portfolio, and even when I've been on with you guys in the past, to me, the thing to watch is the rate of AI adoption. Once it starts to slow, that's when I think we have to, start really thinking about, are we risking excess capacity coming on stream relative to incremental demand? Do I think we're there yet? Not yet.
Right, and there's also some of the studies that have shown that even if there is some experimentation and implementation, it's not yet making those companies money, in any kind of material size or saving them money. In some cases it is, but on the aggregate, it doesn't look like we're yet there. So that's something to watch too. When it comes to NVIDIA and this SoftBank change, now SoftBank says, we're just raising money, and incidentally, some of the money they're raising is going back into OpenAI, which of course, has relationships with NVIDIA and all these other companies. But what do you make of that news, and what should investors be doing with NVIDIA right now?
So when we take a look at like the multi-year backlog, CoreWeave, for example, when you look at the 12.5 million or so Wall Street expects it to, deliver in revenue next year, it's 3.5 times that revenue is where the backlog was exiting the most recent quarter. And remember too, Julie, that's a timestamp of September 30th. And you think about the other deals that we've heard between OpenAI and Microsoft or OpenAI and Amazon, it tells us those backlog numbers are going to go higher. So I think the visibility is very good. I think we need to continue to triangulate, around other data points just to make sure that, yes, that ramp is proceeding as expected. That's why we'll be paying attention to what utilities have to say in terms of their electricity capital spending. What are we seeing from Taiwan Semiconductor, other chip companies, so we can kind of follow along and make sure it's tracking. But to your point, what to do with NVIDIA here, I do think that the SoftBank news is going to, alarm some people. Why pull the whole thing off? We do understand that, much like we do, they have to manage their portfolio, but there's going to be a little shock and awe. I think that's, depending on the size of the sell-off, that could be an opportunity for folks that are underweight NVIDIA to wade in, just like I said with Palantir last.
Interesting. And then NVIDIA earnings are still coming up, right, on November 19th. So I'm curious what type of catalyst you think that's going to be, given that we haven't always seen, even when some of the big tech earnings have been positive on the face of it, the shares have not gone up.
Yeah, so my comment, for the September quarter earnings season, and we'll extend it a little bit to allow for NVIDIA, is that just given where the stocks had been going into the earnings season, they were really going to have to deliver a beat and raise quarter. And in the case of NVIDIA, it can't just raise a little bit, right? There's a lot of expectation around that. So they really need to come in and, knock the cover off the ball. And it appears like they're going to do that. Remember, their quarter end is October. So a lot of these other deals that we heard announced in the last several weeks should be kind of baked into their backlog. So I think we're going to see some good numbers.
What's the latest that you're hearing and seeing regarding the shutdown?
Yeah, so the longest government shutdown in history looks like it is finally winding down. The Senate voted last night to reopen the government, with 8 Democrats joining Republicans, though we did see Republican Senator Rand Paul defect. Now it goes to the House, where Speaker Johnson is teeing up a vote on Wednesday. That is because today is a government holiday, and it is taking time to get House members back to Washington. President Trump has said he will sign this bill, and so we expect the government to open by Thursday, likely, if not Friday. And by the time we get to that point, we are looking at a government shutdown that will have ranged about 6 weeks long. It is expected to hit GDP this quarter, but then we will see a rebound in the first quarter. And the Congressional Budget Office had done some back-of-the-envelope math and had estimated that a 6-week shutdown would amount to a 1.5% hit to GDP in the fourth quarter, but then we would see GDP rebound to 2.2% in Q1. Now, aside from the hit to GDP, as you know, we have been lacking major official government data that investors depend on to assess the economy and that the Federal Reserve depends on to set monetary policy. And so we will likely see the September jobs report released in short order, because that had already been collected as the shutdown had come upon us. However, that data is going to look a bit stale at this point, and it is going to take time to collect new data and put that out. And we have had a government shutdown. There have been a lot of furloughs. So the economic picture is likely to remain foggy here for a bit longer.
Lou, if you told me 6 months ago the government was going to be shut down for 40 more days and the markets were going to continue to trend higher, I'd be like, I don't know, Lou. I'm not so sure about that call. But what has surprised you over the past few weeks?
Yeah, what surprised me is how long this has lasted, right? Most markets react to, shutdowns as political theater, not a real risk. And the markets 12 months later almost invariably are higher. This one, though, K Street really started to hit Main Street. And this is what I'm really concerned about, is that GDP hit. How does it affect the psychology of the consumer when we have a swath of Americans who were going to work without pay? Other Americans have to look at that and go, all right, what other government services that we rely on could hinder the economic growth. So I'm going to be really careful watching if there are any ripple effects. I mean, you see fast casual restaurants like Chipotle struggling, other names in that space as well. Is the consumer really finally hit its breaking point. That's what concerns me the most. But again, I don't trade C-SPAN clips. I trade earnings and cash flows. And the good news is, you brought it out, earnings season is well underway. Earnings have been, by and large, really strong. So I think that creates a lot of opportunities in this market, even as we hit new all-time highs.
Yeah, I'm glad you mentioned those fast casual chains, Lou. We got a story trending on our site right now talking about slot bowls. I guess that's a new term. I guess I missed the boat on that one. But let me just stand on your point there regarding the consumer, Lou, because I share your concern on where many households are. As this data comes in, even though it is backward-looking, how big a risk is it to the market here that it's still at record highs, that some of this data may not be good?
Yeah, I think everyone's going to just put all their eggs in the basket of the Fed cutting rates, right? Expect it to be not good. It's going to paint a picture of a very weak labor market, a consumer that's putting more on credit cards on an absolute dollar basis. And everyone, I think, we've been trained to expect the Fed to cut into that. So we're going to get another 25 basis point cut. I know one of the Fed presidents was suggesting 50 in December. I don't see that. I think they continue on that trend, and that provides the easier spending environment for consumers. I mean, I say this, I'm always looking for the consumer to slow back and slow down, but we haven't seen it historically. I think we've had one period where we've had 2 quarters of declines quarter over quarter in consumer spending. And that was, through the financial crisis and then COVID. Outside of that, the consumer is surprisingly always resilient. So just paying attention to that to see if this is one of those anomalies.
Brooke, what are you keeping
Can I jump in a second?
Yeah, of course. Go ahead, Jen. Go ahead.
So I just want to build on Lou's point, because we have not seen, even though we're going to see a deal to reopen the government, there is no deal yet on those healthcare premiums. And to Lou's point, we are in a K-shaped economy, a bifurcated economy, where the higher end consumer is doing well, but the middle to lower income consumer is increasingly doing poor. And so if they're going to see their healthcare premiums increase, that is going to put further pressure on consumer spending, which has held in here. But I think that is another fly in the ointment and some ripple effects here from the government shutdown.
Don't let your vacation rental and your hammock be invisible. Get seen, get booked on Booking.com.
Grand Canyon University offered nearly $161 million in institutional scholarships to online students in 2024, in addition to federal grants and aid. See what scholarships you may qualify for. Find your purpose. Visit gcu.edu/myoffer.
Modern look.
Market today, it is Tuesday, November 11th.
Boring. It is definitely boring with him. We are not gonna get bored.
The market does.
I don't think.
As a decision maker, you just.
I think we need to watch. And let me just go back to what I was going to show you guys. Stock Market Today Live. Here it is. Edge AI. So this is what I wanted to cover, just because this was being talked about on today's AMD call, Compute Edge AI. So let's watch this video here, and then we will go from there.
Hi everyone, my name is Ivan, and I'm a Senior Solutions Engineer at Gimpulse. And in this talk, there's going to be a lot of buzzwords that we all like together in one place: AI, IoT, LLMs, foundational models. We have it all, and I think it's very exciting to look at how we can combine this all together to drive more productivity growth. And that's another intro slide. So I'll start with a question. There's going to be quite a few questions throughout my presentation. First question is, what is IoT? And I think people who have been in the industry for 20 years still have different answers to this question, because we just cannot figure out. It's so many things at the same time, and everyone has their own answer. Is it a fridge that has a door that can tell you when out of beer, but it has a back door that will send your data out? Like, I don't know. I think from the engineering standpoint, I formulated for myself at least that is the sensing, intelligence, and connectivity. And then you can apply to different things. And then we have sort of figured out the sensing part a long time ago. We have different ways to capture the sensors and all sorts of things from around us. We have figured out connectivity. Honestly, there's a huge market and competition technologies, low power technologies like LoRa, 4G, and things like that. So this is kind of figure out, pick and place. But the intelligence part is something that has been progressing with the type of capacity that we have available in IoT devices. And I'm going to talk about it from a hardware standpoint later, but I think the focus for us is now adding more value into the intelligence part. And the question is, what is the most important graph in tech business? And it's not this one, not this one. It's this one. It's the Gartner hype cycle. And then you can find this hype cycle for a lot of different industries, a lot of different topics. This particular case is the hype cycle for artificial intelligence. So for those of you who don't know, this hype cycle kind of tells you at which stage of adoption and closeness to productivity different technologies are, and how soon they're expected to reach this further desirable plateau of productivity. That, where the computer vision is right now, it means that we now can take this and apply it and get value immediately, and it's understandable and people understand how to use it and why they want to use it. But there's an interesting edge AI part, which I would argue actually goes hand in hand with computer vision. And that's what we're going to focus on today. And you can also notice that while it's kind of in an early stage, it's going to reach the plateau in less than 2 years. This technology is really rapidly evolving, and we see a lot of innovation happening. So another question. I have a lot of questions in this presentation. What does the real world look like? Right? If we look around, we have light, sound, smell, all sorts of signals, the sensing part that we have already figured out. And what we do as humans, if we look around, like I can smell something and I can tell if it's a burger or a pasta, or I can look at the light and say if it's red or green. So our brain is taking a signal that a sensor usually takes and makes an inference based on it and determines what it is, does a classification or a regression or something like that. Now, historically, we've been trying to reproduce this on all sorts of devices, including IoT, and that's what we call heuristical intelligence, heuristical programming. We were seeing the data come in, we were knowing what problem we want to solve, and we were building rules around it, and then we're expecting the system to kind of tell us what's going on based on those rules. But the new approach, this AI at the edge, is when you don't want to set the rules manually, but rather you would give to the program an algorithm all the data that you have, all the classes or problems that you want to solve, and you let the algorithm figure it out on its own. This is way more efficient, but first, just to keep in mind these two things. Data is paramount in both cases, and IoT is all about data. We get a lot of data, we get it from all kinds of sources, but what do we do with it, right? So why is this heuristical approach lacking, and why are we starting to see more and more limitations now of people who are working with these approaches? That the real world is fuzzy, right? Like we can say, okay, I can figure out these two edge cases that I've seen on my production line, and I will set the rules for them. But what if something that I didn't know about happens? How do I know and detect this thing that I will have to fail again and now learn about it? Like, we cannot account for everything. Heuristics are labor intensive. Again, to collect and model all the situations that we want to anticipate, it requires a lot of domain knowledge and just time to do this. And then the insights are being left on the table, right? Again, IoT data. We say we want to detect when a temperature crosses this threshold. But in the same data that I'm collecting, potentially there's so many more different problems that I can extract and solve with exactly the same inputs, but we don't know how to approach it because it's a bit more complex than a threshold, right? So this QR code, you'll see a couple of times. I challenge that everyone has to scan at least one in the presentation and sign up. This is a QR code that will let you register on Edge Impulse, which is a platform that we provide that lets you build a machine learning algorithm, a machine learning pipeline, and deploy it on an edge device. It will be an algorithm that will take sensor data in, any sensor data that you like, any sort of problem that you would like to solve. You will build it using cloud. Of course, training models requires a lot of compute, but then you'll be able to deploy it to any sort of hardware after that. From high level, that's what it looks like, and that's a normal engineering process, right? It's an iterative process. So the platform allows you to do this machine learning engineering with embedded systems in mind, iteratively and quickly, without having to pay attention to like things that are very hard to do. Second question we always get is like, where can I deploy machine learning with this platform? So I made this graph to tell that you can deploy on PC, on MCU, NPU, MPU, whatever you like. But our CTO likes to say it's basically anything under the sun. If you can compile C++ code, this can run there. And that's another kind of overview of what sort of hardware I'm talking about. Any hardware, of course, like for smaller hardware, you'll consider different problems. You will not run a computer vision model on a microcontroller unit, but all sorts of sensor data can have machine learning applied to them and value extracted from them. Right, so I think what I'm trying to say with this is that Edge AI and IoT are having sort of a love story because it's a perfect match. There are a lot of reasons, and I've been having quite a few conversations today where I'm saying the most important thing, I think, is that you're saving on energy costs and on bandwidth. These are the two most expensive things in IoT, in my opinion. We have to pay for ingestion to the cloud. If you stream raw data to the cloud from your huge deployment of sensors, that's a huge cost. Energy costs of devices that are either battery powered, that you have to replace battery every couple of years, is also very expensive. So with running the models directly on the edge, instead of running a camera that will stream all the frames to the cloud and run a big model there, which means you have to send 30 720p images at per second to the cloud, right? It's an enormous amount of data. I think the same point as that is the Edge AI allows you to extend the possibilities of what you thought is possible with IoT. So before, this kind of camera that has an NVIDIA GPU inside, you could only imagine it having connected directly over Ethernet to your local network. What you can do now is connect it via LoRa backhaul, for example. And LoRa doesn't allow you to stream images. LoRa allows you to send one short 124-byte message up. So you do all the processing on the camera, and you send one message, yes or no, over LoRa. So you can now use camera systems in your IoT, low-power IoT systems. Right, but let's take a little step back and actually bring back the point that is shared between all the approaches in engineering that we're trying to do with sensors. Everything starts with data. We don't have a use case or anything to do without data. Gen AI, right? This is a big thing in the last several years. I think it's crazy that I can now write a prompt like this and get this, looks exactly the same, right? It's absolutely similar. Get this slightly cartoonish image out, but still it's like representing the message. But there are other models with the same prompt can generate a photorealistic image that now is resembling the reality. So we can use Gen AI capabilities to augment the data sets that we have, because collecting data and finding the ways how to collect the data is often a very hard task. So what we have added to the platform, and I'm going to show now time series data, but with images we have the same, is the ability to use these big models not to do your job, not to solve your problem, but to help you build a robust solution. For example, this model from 11 Labs is able to generate keywords. So let's see how it works in the platform. I'm putting the phrase that I want to have, and it will generate me several samples.
TechX London 2025. TechX London 2025. TechX London 2025.
So now I can generate a keyword spotting data set without having to touch a microphone. That's pretty amazing. These models are already very good. Another one, imagine I want to build a model that detects glass breaking. I can generate these sounds without having to break glass. I don't want to break anything. I want to build a model that will detect it for me. So that's pretty great, right? Like, it's incredible that we can do these things without having to you know, it's very fast and very large amounts of data that we can generate with the lowest investment, right? But actually, everything starts with labeled data. Because if we have a bunch of data that we collected from the field, but it's not labeled, it's not quality data, it's gonna do us damage rather than help us build a solution. So quality control, as we say, garbage in, garbage out, right? So again, LLMs, right? It's crazy that now I can put an image to, in this case, a ChatGPT or any other LLM model, ask it what's going on. It's not going to tell me there's a person wearing orange. It's going to tell me, which was taken actually at the Olympics, that this is a Dutch national rowing team that's getting a medal, which is already a step further to any sort of like automated process I could do, right? That's great, but it's not applicable directly for IoT use cases because it's very expensive, right? These models are huge. They're not going to fit anywhere. They're very expensive to even compute. And going back to the point, you have to send all those images up. So the costs are growing exponentially. So that's not really feasible. Now, what we can do, again, is to use these models to help us quality control the data we already have, right? Like if I'm building a use case with a lot of images, I'm going to go and collect a video that will have the things of interest for me. But then I would have to label every frame of the video manually, which is a very labor-intensive task. Now, what I can do is to give all my data set to this large language model, and this is how it looks on our platform, and ask it, look at every image you have out of all those 3,000, 4,000, and tell me if there is a hard hat or no. And in 5 minutes, I'm going to have 5,000 labels applied. That's pretty incredible. It's increasing the productivity with which we can now approach these solutions. So what we have so far is that we have these foundation models, big models, LLMs that are incredibly smart and they're very general and they can assist us to build solutions for the edge, which don't have to be that smart because I'm building this model to solve one particular problem at my plant or in my product. I don't need it to know everything in the world. But sometimes it's just not enough, right? So like how else can we be smart and combine them together? We need to take a step back again and actually realize that everything starts with hardware. IoT is hardware, right, in the end. So what the slide that I had before with the IoT is connectivity and hardware and everything. Before, we were trying to develop the technologies on top, like connectivity, but the hardware was limited. We could only run the control logic there and sensing and sending everything up. But now hardware has caught up. We have so many possibilities to put extra intelligence in the same chips that we have and extract value from the sensors that we're sampling. So how we like to say is that edge AI hardware 3+1 layers. 3+1 because these three are actually IoT still, and GPU you could say somewhere in between. It can be an embedded GPU, but 3+1. MCUs and MCUs with NPUs, which is neural processing units, which is dedicated ASICs designed for machine learning inference. MPUs, which is typically Linux systems, and then GPUs and AI accelerators, which are high-end edge ML hardware. So let's take a look. What happened in 2022? A little company called ARM have developed something that is called Ethos. ARM are known for licensing general purpose computing cores, but they said, hey, how do we make a GPU for embedded systems, in quotes, right? So they made this very, very energy efficient and high performant piece of hardware that is able to process machine learning operations very quickly. And because ARM did it, now everyone who works with ARM can just take it and apply it to their designs. Incredible. Now we have a lot of companies like Aleph and Infineon who have solutions with SoCs that have a dedicated NPU on their hardware licensed from ARM. But then companies like ST started looking and said, hey, I want to do it myself, and I can do it better than licensing a thing from ARM. So you see that yellow corner, ST has announced like a couple months ago. So they developed this STM32N6. You can see this kit in our booth, 152. We have, you can look at it. But basically now they developed their own silicon accelerator for 600 gigaops, which means that MCU-grade device, MCU-grade power consumption, you can run YOLO V8 at 15 FPS. It's incredible. Second, mid-end computer vision. You have things like NXP, who used ARM, also dedicated acceleration, and Renesas, who build their own IP. Amazing. This, you can already connect several cameras and have a Linux system and way more complex. And then you have high-end computer vision systems. This is where you can run 10 models at the same time, 10 camera streams at 60 FPS and put it in robotics applications, things like that. This hardware now, you can just grab everything and make things run locally that you could never imagine before. So we can be a little bit even more smart and say, hey, how about I run a very simple model. It's called anomaly detection that says, is there something I don't know in the frame, yes or no? Is there something that's not supposed to be on the floor? This model will tell you yes or no, but as soon as it happens, I can only then send this image to GPT or, with the last level of devices, to an on-device LLM or VLM, and get an insight of what's actually happening. So this kind of solution I see in the coming year becoming way more prominent and interesting because the hardware allows to do these things, which is, I think, my personal highlight of the coming year. And this is a small demo of it in action. There's an anomaly detection model running, and you see the cascade is not enabled, so we're not sending anything up. We're not sending anything to ChatGPT, but now I'm sending only these frames. If I were to do it for every frame, I would spend all that money that I was talking about. Now it's out. There's no anomalies. I'm not sending anything. It's running just on the device. And now a signature prop of Edge Impulse, a bottle of beer bottles. Yeah, so I can balance kind of, if I know that this one is not going to happen very often, I can still offload it and you know, use the bigger computational expensive things. Right, so just to reiterate, I think all these points, now is the time when the hardware and software are at the point where we can, in the same solutions, distributed low-power IoT devices, get way more intelligence from the data we're already collecting and having. Last question. I had a lot. What is the most important thing for emerging technologies? I think it's always, I like showing this. This is a great thing because we are all developers in one way or the other. We all know developers who we as managers will come to and say, I want this, but you need a developer who will take it, implement it, test it, and do everything you want for it. So that's why we at Edge Impulse, the platform that you've seen before, we have made it so that you can access it for free, you can use it for free, you can access most of the features for free, you can even use the outputs of the platform, such as models and use cases, in commercial applications for free. Because if this technology is getting adapted by everyone and everyone is speaking the same language and knows how to, which hardware to use, which use cases to build, this makes us all way more productive and coming up with incredible new things that can help us. So another QR code. Those who missed the last two, this is your last chance. No, actually not the last one. But yeah, sign up, immediate platform access. You can, do all this, talk to us.
These are the founders of the papers that most people missed. And
all right, well, that was kind of a cool summary of Edge AI. So Wes Roth, this guy is like, he looks at everything around AI and anything that's coming out that's kind of changing the industry. And so I've always thought Google was gonna win the end game at the end of the day. So this is looks like he found something with Google, and let's see what he's talking about here, because I really do think that Google's biggest strength is that biggest weakness is that they can't show their strength. If they show their strength, I think they're going to be investigated, or they're going to be accused of monopoly. So they have to kind of roll things out very slowly, but in reality they are ahead like by 10 years compared to other companies and what they are innovating right now.
these are the founders of the hottest AI startup in the Bay Area. Their names are Sergey Brin and Larry Page. And yes, they founded Google. Everyone knows Google. Here's what you don't know. There were a few papers published by Google just in the last month or so that really give us a glimpse into where they're going. The impacts of these papers should be massive. This is not clickbait. This is not hype. The implications of these papers are staggering. However, this just gets lost in the noise of AI news and everything that's happening. In this video, I'll show you what Google is quietly publishing. These are papers that most people missed. And I'll also show you why the next Google just might be Google, and the other frontier AI labs might be cooked. Now, I know that's a very bold claim, but I'll show you why it's not absolutely insane. Now, you may have seen that Michael J. Burry shorted the living bejesus out of NVIDIA and Palantir. A lot of people are talking about a bubble. Michael J. Burry, by the way, is the guy that shorted the 2008-2009 housing market crash and did really, really well for himself. He just nailed that call, and a lot of people listen to him when he's shorting something or pointing out certain bubbles or things that are about to pop. He doesn't always get them right, but when he does, it's pretty spectacular. So with that in mind, what are the biggest issues that are stopping AI progress? Number one is chips. Compute, GPUs, we have a limit in how much we can produce. NVIDIA is getting very, very wealthy from this shortage, and they're selling GPUs like hotcakes. Number two is energy, aka electricity. We're not producing anywhere near the amount of electricity we need to power all these AI data centers. With these two, you can probably reverse them depending on how you look at it. Energy might be the biggest problem. Next is continuous learning. This is the big stumbling block with large language models. In fact, at this point, Demis Hassabis and lots of other leaders in the AI space basically said that without continuous learning, these models won't ever be truly useful. It's like if you have a brilliant coworker that just immediately forgets any new information. He can't remember your name, where he sits. He's completely incapable of retaining any new skills or data or knowledge that he learns. How useful is that person? I mean, they're probably still pretty useful. If they're smart, they know a lot of things, they can draw on their past knowledge, they're still useful, just like a large language model can be extremely useful. But without that ability to keep learning, it's just severely limited. That's where LLMs are right now. Without continuous learning, we won't really crack AGI. And finally, we have profit, revenue, income. A lot of people are saying that the capital expenditures of these AI labs, the amount of money that they're spending on chips and factories and AI data centers is staggering, right? It's in the trillions now. How are they going to make that money back? How are they going to make profit or revenue or income on these AI technologies? Each one of these is kind of an open problem. Who's going to be the one to step up and solve these issues? Google might have already solved them all. Now, that might be a little bit hyperbolic. They didn't solve them completely, but I'll show you why they have been working on them and why these just might be solved by Google within the next few years. Have you ever wished you could literally talk to your code base? Like you just tell your site, add a checkout page, make it dark mode, and fix the layout, and it just happens? That's exactly what Matter from JetBrains, the sponsor of today's video, does. It's an AI development companion that lets you prototype directly in the real code base. No coding required. Most AI builders out there stop at mockups or quick demos. Matter goes further. It actually works inside your repo. So if you're a product designer or a PM, you can open Matter, connect your GitHub project, and start changing the real app by chatting, just like you would with ChatGPT. Except now you're changing the live code and seeing it update instantly in the preview. Let me show you how. Here's a simple e-commerce store. Our checkout abandonment rate is rather high. Matter gets to work making this into a single page checkout. Checkout flow redesigned as a single page. And instantly, there it is. The UI updates right beside the chat window. I can test it, click through, and if I like it, can even create a GitHub pull request directly from Matter. Everything happens in an isolated environment, so my production code stays safe. And because it's collaborative, I can invite team members right into the same chat. We can tweak colors, layouts, or flows together live and share the preview like a Figma file. Matter basically kills the handoff problem. No more endless back and forth between design and engineering. Designers and PMs can build prototypes with real data. Developers get clear context, generated code, and documentation they can merge instantly. If you're tired of throwaway prototypes and want to move straight from idea to real app, check out Matter by JetBrains. It's the AI development companion that helps teams build twice as fast. You can try it right now using the link in the description. Let's start with continuous learning. Google recently published this paper just a few days ago introducing nested learning, a new machine learning paradigm for continual learning. So what we're talking about here is something that's similar to how the human brain processes and stores information. We refer to it as neuroplasticity or at least that's one of the important processes that allow us to do all the wonderful things that we do. As Google states here, when it comes to continual learning and self-improvement, the human brain is the gold standard. It adapts through neuroplasticity, the remarkable capacity to change its structure in response to new experiences, memories, and learning. Without this ability, a person is limited to the immediate context, kind of like anterograde amnesia. Anterograde amnesia is the inability to create new memories after an event that caused amnesia. So you're continuously forgetting all the new information that's coming in. You're just not able to store it. You can rely on your past experiences, and you can kind of rely on the short-term kind of context that's in front of you. Like if you're having a conversation, you might be able to keep up with the conversation. But once you get outside of that sort of a context window, you can no longer recall those details. And they're saying we see a similar limitation in current LLMs. Their knowledge is confined to either the immediate context of their input window or the static information that they learn during pre-training. So this new approach, the nested loops, you can almost think of it as quick, fast, inside loops, right? These go very, very fast and they update continuously or quickly. This is kind of like short-term memory. Those are like the red, quick inside loops. And you have these longer loops that update not as frequently and they run slower. This is like the long-term memory. So they're kind of operating at different time scales. This unifies kind of the architecture of these models as well as the optimization of these models under kind of one umbrella. By the way, the people behind this paper, these are the same researchers that proposed the Titans architecture, learning to memorize at test time. Google has a group of researchers that seemingly are approaching potentially cracking this problem of continuous learning. Not only that, but they're publishing the results, and they've tested this approach, this nested learning, through a proof of concept self-modifying architecture they call HOPE. So basically this is showing that potentially we'll have large language models that will be capable of learning on the job, if you will. Kind of a big deal. Okay, so let's say we're approaching potentially cracking this continuous learning problem. Google seems to have some architectures, some approaches in place that may in the future let these large language models learn on the job. That's great. So what? How do we turn that into printing money? We like money. We like profit. How does that make us money? Here's something that I think a lot of people don't understand about these AI models. These models are tokens in and then tokens out. We put tokens in, we take tokens out. So tokens in is the data. It's the data that we feed into it. And tokens out are predictions. So right now, when we think about AI, the most common thing that we know about is large language models, where tokens are words, right? So we take words, we tokenize them, and we feed them into this AI model, the large language model. And those words are basically the entire internet, textbooks, just everything that humans have written. We feed it into it, and we train it to predict the next token that comes out. This is why people oftentimes will try to dismiss these AI models. Large language models are just advanced autocomplete, next word prediction. Now, if you've been following my channel, I've often complained about this take, saying it's not a very good take. It's not a very smart take. It's probably not correct. Or if it's correct technically, then it's still meaningless because obviously these models are doing a lot more than just statistically predicting the thing that comes next. There's a paper out of Harvard, for example, showing that they build something that can be thought of as mental models in order to be better able to predict what the output should be. And there's even more confirmation now. So this is yet another research paper from Google. Shockingly, are you surprised? Google's doing also fundamental research into how this stuff works. They're saying LLMs don't just memorize, they build a geometric map that helps them reason. So the people that don't really believe in the power of LLMs or whatever you want to call it, that think it's just a stochastic parrot, their big sort of counter argument is, well, they're just predicting the next word. So if I say, I like my coffee with sugar and, right, they look at all the text that they've seen, and just based on statistics, they're like, oh, so the next word would be, I forget what I said, sugar and cream, right? So they're just making an association between those words, so they're able to predict what comes next. Well, I'm really sorry to say that that theory is just blown out of the water by this paper. So they're saying here that transformers, so kind of the architecture of these large language models, their reasoning that is incompatible with memory as strictly a storage of the local co-occurrences specified during training. So in our coffee and cream and sugar example, it's not that they're just memorizing coffee and cream and sugar, how they go together, those kind of local cluster of concepts like, oh, if they're talking about coffee, then what are other words that are sort of statistically relevant? Well, sugar and cream, and those things are kind of clustered together. And that's how it knows that, when you say coffee, it thinks, oh, maybe we talk about sugar and cream. So that would be a local relationship, right? But they're saying here that their findings show that this explanation is incompatible with what they're seeing. So the idea that it's just clustered local pairs, doesn't seem to be what's happening. Instead, the model must have somehow synthesized its own geometry of atomic facts, encoding global relationships between all entities, including non-co-occurring ones. This in turn has simplified a hard reasoning task involving, let's say, a complex sequence or ways of connecting two facts into an easy-to-learn one-step task. So how we visualize how these AIs store information, and they're in these like vector relationships between different words, right? So man has some relationship to the word woman. King has some relationship to the word queen. And if I ask you like a question like, a man is to a woman as a king is to a, right, and I left this blank, you would be able to guess what this is based on the relationship of these two, but also kind of the relationships of this vector and this vector of meaning. And this is kind of a good, simple way to kind of illustrate how they sort of map meaning onto words. Each word is connected to other words that are related. That's what we thought. What this paper seemingly shows that each word or each knowledge cluster is connected to all other knowledge clusters or all other concepts, or as they call it here, atomic facts. These models encode global relationships between all entities, including non-co-occurring ones. So these would be co-occurring ones, right? So yes, it has some relationship between man and woman, king and queen, but also each one of these is connected to everything else. So I think a good way of thinking about this is each star in the universe has some relationship to another star, like the distance in 3D space, right? So you can kind of say how far they are apart, in which direction. So there's kind of a vector connecting them. Vector is like distance plus magnitude. So it's over there, far away, kind of is a vector. And each star, you can make a vector between it and every other star in the universe. You can describe the relationship between all of the stars, not just ones that are clustered together, that share some sort of meaning or co-occurrence, just to everything. So coming back to our words and tokens, tokens in, tokens out, right? So right now we tend to think of them as tokens. In fact, a lot of people out there that don't really follow AI, they think of AI as the sort of the output, whatever it is, right? So you make an image of something, they're like, that's AI, or, it's a chatbot, that's AI. And if the image is good, right, they're like, oh, AI is good. And if the image is bad, they're like, oh, AI is bad. That's kind of like judging how valuable electricity is based on how well one particular light bulb works, right? This light bulb kind of sucks. It's flickering. Therefore, electricity as just an invention, as a concept, like all of it is just bad, right? That's kind of a silly take to have. AI is taking massive amounts of data and using computers to compress them so that it forms these relationships between all of these little data points. And then we can ask it questions about how those different points are interconnected. And we can pretty much do this with anything, assuming we have enough data. Why is that important? Well, in part because of this recent Google paper released October 15th, 2025, less than 1 month ago, saying how a JAMA model helped discover a new potential cancer therapy pathway. So this is a new 27 billion parameter foundation model designed to understand the language of individual cells. So JAMA, you might have heard, so there's other large language models under the JAMA family of umbrellas. They are open source and they're language models, right? So they're tokens in, tokens out, but our tokens, they're words. That makes it a large language model. right? Words, large language model. But here's the thing, it doesn't have to be words. It can be DNA. It can be proteins. It can be biology. It can be anything. It doesn't have to be words. That same architecture, if you feed enough stuff into it, it can start predicting useful information about that stuff. So in this case, in this example, they're taking this large language model and they're training it on a corpus comprising of over 1 billion tokens of transcriptomic data, biological text, and metadata. So this is a single cell RNA sequencing, etc. So the point is you don't have to understand what exactly this is. The point is that we have a bunch of sort of letters that make up sentences, and those sentences tell us how our bodies work, right? I mean, that's kind of how DNA works, right? You have letters, you have sentences, and that creates this, and that encodes how we are made, how we exist, etc. Amino acids are also, you can think of them as, words or sentences. They make up proteins. That's kind of the building blocks of life. Kind of works very similar to, again, words and sentences in the language that we speak. This is not too dissimilar, right? So instead of words, right? So we take words and then this thing predicts how a sentence gets completed or how to answer a question. We can feed it like life, right? So the sequenced DNA, the sequence of amino acids, we can feed that into the AI and then get predictions about what? Well, in this case, how to treat cancer. But also think about it for anything, how to treat any disease, how to create any drug, how to modify any biological process, potentially. So why is that important? Well, we know that as we scale these models up, they get better at certain tasks. So this is large language models, right, on various different tasks. This black line here, that's the human level, right? So as we scale them up, they sometimes cross the human level, right? So more data, bigger models, those are kind of the scaling laws. Scale them up enough, they get better than humans at certain tasks and potentially superhuman and on. So with this JAMA model, they asked it to find a very specific treatment for cancer under certain very specific conditions. So it was kind of like a very complicated question. Right. So instead of asking it like, what is 2 + 2, which is a very simple question that even a small model can answer, they're saying solve this very complicated puzzle with these specific constraints. And it does. It creates some novel approaches that could be potentially new pathways for developing cancer therapies to fight cancer. Why is that important? Because they're saying we demonstrate that biological models follow clear scaling laws, just like with natural language. Larger models perform better on biology. The question is, do they just get better at existing tasks, or can they acquire entirely new capabilities? Well, the thing that they were able to find, well, this required a level of conditional reasoning that appeared to be an emergent capability of scale. Our smaller models could not resolve this context-dependent effect. So that means that these biological models kind of work just the same that these large language models do. So just like this approach can get it really good at coding or writing stories or whatever, even things like math and science, but we can also apply that to just about anything where we have data, right? So we can put in, how life works and ask it questions about, okay, sort of based on this, how do we create a cancer treatment? How do we solve this disease? How do we create this drug? So we put data in, whatever type of data that is, and we get predictions out. And these could be images, right? And then we get things like Midjourney that creates beautiful images. We can put music in and we get something like Suno that can create beautiful music. LMs create words and math proofs, etc. They have this general reasoning abilities. Google used these models to help them with their quantum research, some sort of a quantum correcting mechanism, right? So we feed in the data on quantum fluctuations, and it helps us predict these quantum fluctuations. AlphaFold, it learned to predict the 3D structure of proteins. That JAMA model, right? So we fed in, I'm not exactly sure what they did. So it's some sort of a cell sequences plus biological data, like tons of stuff that they fed in. And now it's spitting out candidates for therapy treatments under these like very specific conditions. So some pretty complicated stuff. With things like AlphaVol from Google, we've seen it create better hardware. We've seen it optimize data centers. So ask yourself this question. If these systems, these large language models that we're working on and doing a lot of research into improving, if they could be also used, in a little bit different format, like this Gemma model, right? Still the same kind of a large language model structure, but it's fed in biological data. So if we could use that same technology to make better drugs, to solve disease, to create better building materials, to create better energy sources, to create better business plans. Like there's not a limit to how much you can do, but what Google's focusing on right now quite a bit is the medical side of it, drug discovery, etc. If they were able to discover better drugs faster, solve all sorts of diseases, maybe at some point even expand human lifespan, do you think they could make a buck or two off of these models? I think so. So next two things, chips and energy. Let's talk about energy. I've covered this at length in a different video, but there's this thing called Project Suncatcher. This is Google's mission to put AI data centers in space. In space, the solar panels can take in a lot more energy, right? There's no day and night cycle. If you're in the right orbit, right? Sun shines 24 hours a day. Also, if you think about the fact that if we keep 10xing how much energy we produce, even if we find some good approach, some efficient approach to doing that, eventually just the amount of heat that we're dumping into our atmosphere becomes a problem. So we can't just keep 10xing it, even if there's some really cheap energy source. Putting it out in space greatly solves that problem. Like you can dump a lot of heat in space without an issue. In this paper, and again, I covered it in a different video if you want to watch, but basically they go line by line and they're like, how realistic is this? And they show us line by line that it's very realistic. Space radiation is not a problem. Energy efficiency is not a problem. Transferring data between these solar-powered satellites is not a problem. They have a solution to every single problem. The only problem right now is this, that if you build a power plant here on Earth, it's going to cost you this much per unit of electricity, let's say. And if you build these power centers in space, right, it's going to cost you many, many times more, like so much more. It's not really feasible to do it, right? It's a lot more expensive to send stuff up there and build everything there. The reason it's so expensive is because of the price per kilogram for sending stuff into low Earth orbit. Right, so right now this number is like $1,500 per kilo to send the stuff needed to space. In order for this to be the same as building a factory on Earth, that has to be $200 per kilo. So 1,500, we need to get it to 200, so not quite feasible yet. But guess what? Based on current projections, this will hit this number by 2035. So if all the assumptions are correct, by 2035, it will be the same price to build AI data centers with their own energy sources. So you don't need a separate power plant. It's all in one self-powered AI data center, training these models, doing inference, and just beaming everything back to Earth. That'll be the same price kind of per unit of electricity as building this on Earth by 2035. And by 2027, in a year and change, Google is sending an actual prototype of 2 satellites into space to test this out, like in reality. So really, they kind of have a solution planned for energy. Now, you might be saying, yeah, but that's not, anytime soon. Who cares? Those 5 years, 10 years, they will pass. These issues, these problems, they will still exist. Google isn't trying to win this year, next year, or 3 years from now. It's like that saying, he who laughs last the hardest. Is that the saying? Basically, it doesn't matter how much you win in the short term. You just want to be the winner at the end. Google is setting up to be the winner at the end of this race with enough energy to power their data centers, with continuous learning models, with profitable models that they can make billions and perhaps trillions of dollars with. I mean, if you're solving all disease, how much money do you think that's worth? You can probably make a buck or two off of that. So everything comes down to chips. Does this mean that NVIDIA just becomes a super mega wealthy off of the back of Google because they're the supplier of chips? Well, not quite. Google has some very impressive chips. Recently, they have announced the 7th generation TPU Ironwood. Even Elon Musk is impressed by their ability to make these chips. Will Google start selling their TPUs and compete with NVIDIA? We're not sure, but yes, they will. In fact, they already have a deal with Anthropic that allows them to rent those chips out to Anthropic for their purposes. Very likely, they're not going to sell them kind of like NVIDIA does, to where you can just like take it home and install it somewhere. It's probably going to be mostly through the cloud with all that infrastructure built in. So you're just like renting them for your needs. So more of a closed kind of ecosystem. Out of all the options on the market today, TPUs are the closest alternative to NVIDIA's GPUs. And TPUs are specialized for machine learning and AI workloads. In the right application, they can deliver significantly better performance per dollar compared to GPUs, requiring much less energy and producing less heat. And we believe that Google is at least 2 years away because they're building the ecosystem, right? So they're not trying to announce before they're ready. By the time they announce this initiative, they're going to have massive capacity. They're going to have everything just humming along, optimized, no bugs, no issues. TPUs are also, it sounds like, according to this person, are becoming more multimodal. They're not only used for training, but effective at both training and inference. Google might become a very serious competitor to NVIDIA. And that's what makes it different from xAI, OpenAI, Anthropic, all the Chinese labs, everybody else in the game of training up models. There's only one model that has behind it a fairly serious chip, manufacturer, designer, etc. And that AI model is Gemini, and the company is Google. So I hope you see now that the biggest issues facing a lot of these frontier AI labs, Google has solutions to them. So I'm not saying problem solved quite yet, but they have a roadmap to achieving them in the future. They have the capital, the money to achieve it in the future. They have the resources, the infrastructure to create all the chips that they might need, plus sell them to other players. They have a very interesting kind of medium to long-term solution for energy issues specifically for data centers, right? So if they're doing that, it's not going to affect our energy bill. It's not going to take away from the capacity of power plants here, on the planet. And it's not going to heat up the atmosphere if we keep 10xing our need for energy. Now, that energy production is limited to anything that we can put out of space. Right now, we can't really beam energy back to the planet. I mean, there's some proposals for using microwave energy to generate energy in space and then beam it back to the planet. But that's also a little bit scary, right? That could be used as a weapon. Or like, what if you miss? It just sounds like a problem. Imagine just beaming tons of energy at the Earth's surface. I mean, that's kind of literally the Death Star, right? But for anything that we can put out in space, assuming it's cheap enough to launch stuff up there, it's probably going to be a lot cheaper to just have it generate energy in space. The sun is a massive source of free energy if we can just harvest it. By the way, can you tell what this is an image of? Take a look at it. I know it's a little bit blurry, but could you describe what it is? I'll give you a hint. It's a satellite image, so it's an image from space. So what are you looking at? What is this line here, this centerpiece? It's kind of hard to tell, but it's a river, right? You can maybe kind of guess at it. So interestingly, Gemini 2.5 is pretty good at identifying these images, like images from space. We give it satellite data, and it kind of can figure out what is agriculture versus a river versus a forest versus a population center. It couldn't get this one, but I think it makes sense why. It's kind of hard to understand what you're looking at. But the scientists at Google, you guessed it, so this is unlocking multispectral data with Gemini. They decided to test it if it could become better at figuring out these satellite images with, if it could see more colors than we do. What if you could give your AI superhuman vision? What if it could see in wavelengths invisible to the human eye to understand the world in a fundamental new way? And thanks to Gemini, you don't need a custom trained specialized model anymore. You can start analyzing complex satellite data right out of the box. Simply by giving Gemini 2.5 the same model we have access to, not some specially trained model, but you give it access to that multi-spectrum vision data, all of a sudden it starts classifying these things a lot better. Now, how does this affect Google's stock price? Are we in a bubble? Is there going to be a correction? I have no idea. I love the quote in The Wolf of Wall Street. And that is a number one rule of Wall Street: nobody, and I don't care if you're Warren Buffett or if you're Jimmy Buffett, nobody knows if a stock is going to go up, down, sideways, or in circle. It's a fugazi. It's a wazi. It's a woodsy. It's a fairy dust. It doesn't exist. So are stocks going to go up? Are they going to go down? Are they going to go all over the place? I don't know. I don't really care. And I'm not really talking about stock prices here. What I'm seeing, and let me know what you think about this, but I'm definitely seeing that Google is kind of beginning to snowball. It's thinking long term and it's building out the AI infrastructure. Solar power AI data centers in space, continuous learning models, the massive amounts of chips needed to run training, to run inference. Specifically, those chips are created for machine learning and AI, not sort of general parallelization use. GPUs are great for everything. TPUs are more tailored for AI. And at the same time, they're beginning to start that drug discovery process, trying to work with pharmaceutical companies. They're planning at least 20 years in the future, thinking about where's this heading? Let's start building the infrastructure we need to get there. So keep that in mind as people are talking about the bubble and whether or not chatbots are going to displace all workers and if chatbots are going to be able to make trillions of dollars. This post kind of made me crack up. Inside you, there are tools. One is AI is a bubble, and two is no one is pricing in AGI. Point being is AI and AGI, that's coming. All the insane scientific and technological progress that comes with it, that's coming. Are the stock price charts between now and then, are they going to be a straight line or a squiggly one? I don't know, and I don't care. A lot of people seem to think that if the AI bubble pops, then AI just ceases to exist. It goes away, it disappears. Whatever happens, that is not happening. So pay attention. I hope you enjoyed this one. Please make sure you like and subscribe.
That was a pretty cool review. I've always loved Google. I remember when Google was like around 100 and maybe $60. I was saying, buy. This is a great company. And no one was really looking at it. So Google. And finally, when Google decided to come up with Gemini and everything else, and then the whole thing with Chrome, monopoly fell off. Google just started taking off. I was saying buy Google right around here, 170. And finally just took off and didn't slow down. So year to date, 53%, 1 year, 62, max 200, 5 years, it's a 235, max almost 1,000% return. Long term, if you find a good company, it's always a win. Like long term, a good company that's thinking of the future is always going to win. Let's get something Wes talked about.
You gotta be flipping my flapjack.
Something that Wes was talking about is that just the fact that we're starting to send different
Star Cloud 1 separation.
And we're building infrastructure, AI infrastructure in space, and NVIDIA's NVIDIA-backed startup StarCloud sends AI equipment to satellite to space. So finally they're doing it. And I even showed that video, and this is the future. We're going to start building data centers in space. As one of the most powerful AI chips ever set up in space, and without it, blocks for why let's listen to this.
The size of small cities packed with rows after rows of servers and GPUs powering everything from your TikTok feeds to autonomous drones. But the problem is that data centers take up a ton of space and they need a huge amount of energy, lots of water to stay cool. But a lot of the big tech giants are now starting to look up way above us. Google, SpaceX, Amazon, they are all exploring data centers in orbit, powered by the sun's rays and cooled by the vacuum of space. No water, no land footprint, and unlimited energy up there. Then enter StarCloud, the NVIDIA-backed startup building the future of orbital computing with plans to build a space-sized data center the size of Midtown Manhattan. Joining us now is the CEO of StarCloud, Philip Johnson. Thank you so much for being with us. Starting with the launch, the deployment, looked like everything went according to plan. Is it working up there?
Hello, Gadi. Well, thanks so much for having me to start. Yes, so far so good. All is going to plan. So on the weekend, we deployed our first satellite. That's the one on the video you see. And so far, we've made contact with the satellite, and we have now 2 weeks of commissioning, and then we'll turn on the chips and be the first to run those chips in space.
Wow. So in 2 weeks, the real space computing starts. I know, like, this is so exciting for anybody that follows this space. We collect massive amounts of data in space. The bottleneck has always been getting it back down to Earth. It's one of the reasons why, we see like satellite images, we don't see satellite video. How does this address the bottleneck?
Yeah, that's a great point. So for the first few years, the main use case is we're going to be processing imagery on orbit. So rather than having to wait for a ground station, right now you might have to wait a few hours to a few days to get one image back. Instead, they'll be able to, satellites will use us to process data in orbit, and then we can just downlink the insight. And that insight might be, for example, the location of a wildfire in California. And so that's the kind of thing you really want to get back much quicker.
And yesterday we saw one of your competitors make a big announcement. There's one thing, look, and your animations are amazing, but there's a difference between animations and then real video from space. Obviously, you guys are the first in that frontier. How do you see competition developing? Because it does seem like you guys are the first, but all the big tech giants are looking to be nipping at your heels.
Yeah, so when we started a year and a half ago, lots of people thought that this was impossible, actually. And the first demonstrator that we've put up, the whole purpose is to prove that we can actually run this type of chip in space. But as you mentioned, there's lots of competition coming now. It looks like all of the hyperscalers have realized that this is going to be an enormous industry. We're looking to partner with certain players. We announced a partnership with Crusoe. They're one of the biggest data center builders. They're building the data center for OpenAI, the Stargate data center. So yeah, we're looking to partner with folks.
And when you look at all the advantages of space, what are the ones that stand out to you? Is it the sun? Is it the lack of heat? What is it that you think is really setting this apart?
You've hit the nail on the head with those 2 points. So the first is almost unlimited low-cost energy in the form of solar. And then the second is we can dissipate that heat out in infrared into the vacuum of space. So we have these huge deployable radiators that emit heat in infrared. So those are the two big advantages, as well as not having to go through long permitting cycles on Earth. That's really it.
So those two plus red tape here on Earth, that is an unexpected one. Philip Johnson, really appreciate your time and looking forward to seeing how this all scales up. Thank you so much for your time.
There you go. So we're already sending freaking StarCloud is sending satellites to space that are gonna have we're gonna start building data centers in space. We're gonna start training and everything else in space. Pretty impressive. So that's it. I think I've been on for almost 5 hours. It is the end of the day. Thank you so much for joining me. Hopefully you enjoyed this session. If you did, make sure you subscribe. Have a great night. Peace.